Akombi Ojon has a BSc in geology from the University of Calabar and an MSc and a PhD from UNN. Please, can we please give a round of a virtual clap to Dr. Romeo? When I contacted him for this, he did not hesitate. He did dive into this. Please, if you're on this call, give a clap. All right? Give a clap to him. Let me see the reaction. Use the reaction button. Encourage him with a hand clap. All right? All right. We're shifting gears. The next person I would like to introduce to us is Dr. Okon Emmanuel Etim. He's a consultant geoscientist and a senior lecturer in the Department of Geology, University of Calabar, and the current faculty advisor for Society of Petroleum Exploration is SPE, University of Calabar, student chapter. He is a lead researcher of the Geo-Resource Research Group in the Department of Geology, Faculty of Physical Science, University of Calabar. He is a seasoned academic and a team player and has since been engaged in teaching and mentoring young geoscientists since 2013. Dr. Okon obtained his BSc Geology and a PhD Sedimentology from the University of Calabar in the year 2006 and 2001, respectively, and an MSc in Petroleum Geology / Sedimentology from the University of Ibadan in 2011. His academic awards include the year 2016 NMGS / Total Award for the Best Paper Presentation, first prize, at the Nigerian Mining and Geoscience Society International Conference and Exhibition, which included all expense-paid visits to the Total Technical and Research Center located at Pau in France. Dr. Okon is a guest editor of the special issue of Global Journal of Pure and Applied Science. He published quite a number of papers in honor of the founder of the Global Journal series, Professor Bath Woye Ekweme, in the year 2025, and indexed it in African Journal Online, AGOL, EBSCO, and Google Scholar and ProQuest. His research interest is in the field of clastic and carbonate sedimentology, paleometallurgy, paleoceanographic, and paleoenvironmental reconstruction, sedimentary geochemistry, mineral exploration, and the application of remote sensing to solving geological problems. He is currently team member of the National Geographic Explorer Grant 2022, where their research interest spans the significance of speleotherms of carbonate rocks in paleoclimate studies. In addition, he is a member of the several professional bodies, including Nigerian Mining and Geoscience Society, NMGS, Nigerian Association of Petroleum Exploration, International Association, and the rest. So, his dossier can take us the next 30 minutes. So I'm going to stop here, right? Because we have time limit constraint. If you want to meet Dr. Okon, you can DM me. I will share his contact with you. The same thing with Dr. Romeo, okay? All right, that's it. Dr. Obi Ifine, our own, is someone that we know, and he will talk when he comes up on board, and also the EIC. Okay, sharing our agenda again, just so that we can keep on track. Dr. Obi, I yield the mic to you now at this point.
Okay, thank you. Good morning, everyone. Welcome again, and apologies for the small gap we had. I mean, we're field geologists, right? So sometimes we make all the plans and things happen, but being the geoscientists that we are, we quickly adjust. I think Um, Oga Abiodun Adesan, your hand is up. Did you connect, sir? You have your hand raised. You want to go ahead? Let me stop. Or was it a past one?
No,
Okay.
sorry, it was an error.
Okay, no problem. Thank you very much, sir. Thank you. Thank you. So thanks everyone for coming back in. I think I'll very quickly just take us through the how to basically for the tool. It's a traditional thing that we do every year. But the more important thing is when you begin, when you engage, you will, of course, see how this works eventually. So I'm going to share, AIC, if it's okay, I'm going to share my screen. Let me know if it's come up, if you can see my screen.
Yes, it's up.
Okay, great. So this is a bit of a brief on navigation guide. I'm sure those in the chat room, you all have the links. And if you are here and you do not have the link, we will share the link to each location as we progress. So I think Austin or Tunde, the link to each location will be shared real time. But when you open it up, a window will pop up and then you will see different icons at the top, right? You click to start the field trip itself. And then when you do that, you will be able to, click on the different icons at the top. For example, regional context. When you click on that, you see general information on that. If you are in a location where you have, let's say, icons like this, those represent close-up captures or close-up pictures. So when you click on them, it will show you a closer view of that location, of that feature. Okay. And then it depends on what it is. You will probably see location map also on the top icon. When you click on it, to show you a base map. The good thing is this is interactive. The instructor will guide you and you also will be doing it real time. The idea is for you to have a feel of what it felt like being there at that location and then making observations at the different locations. Okay, so this is just a quick intro. The links will be shared for, let's say, the first location after the regional structural introduction. And then we will go ahead and walk you through the different icons and what they mean. And as, of course, more importantly, you will do it yourself to see what it means. Some will show you map. Some will have will be a recorded video like you see here. Some will be a stratigraphic column, just the different tabs up there. And then there's also a downloadable version of the VFT guidebook. In fact, that might be the first thing you may want to do when you get the link for location 1. It is the same for all locations. So when you click on it, it will automatically download the guidebook for this field trip. So all the locations that we visited, there's been detailed description with pictures, and that's all summarized and put in the VFT guidebook. So that is just for your notes. And then every other thing, the instructor will guide you through it. Thank you.
Okay, Austin, are you up? If there's any, okay, so Austin, if he needs to add anything up, we can bring him up later. Shifting gears. This is when we take a 10-minute short break. Or do we really need to do that? If we don't need to do that, we can just move on to the caliber flank itself proper. Dr. Ifeanyi?
Yes, okay. Just give me a second.
Ah,
I'll stop sharing so that you're able to share, okay?
Okay, just give me a second. I'm gonna. So I'll start with a video. I think 2 videos actually, introducing the caliber flank, which we have done. So let me know. I hope the sound comes up, but let me just start with that one. So let me know if you can see my screen showing a young man in the field.
We can see the young man with a black hat.
Okay, the next will be to confirm. I'm going to play it. Let me know if you can hear the sound. I'm going to press play.
My name is Dr. Romeo Ojong.
Can you hear the sound?
Yeah.
I hear this.
Yes, we can.
I hear
Okay,
Yes, we can
great.
hear it.
Okay, great. I'm going to stop and then restart again. After this video, a second one will play, and then we'll do a quick 5-minute talk, and then we'll move on.
My name is Dr. Romeo Ojong, and we are here within the Calabar flank. We are standing at the contact, the basement sediment contact of Calabar flank, where the Awi formation, which is the first formation within the Calabar flank, sitting on the basement. Generally, the term Calabar flank was first introduced by Morad in 1972, who described Calabar flank as that part of sedimentary basin which is
We've lost audio, Dr. Ifeanyi.
close to the Penn
Okay, it's back.
basin, which is bordered the north by the Oban Massif, to the south by Niger Delta, to the east by the Ikwe platform, and to the west by Cameroon volcanic ridge. Structurally, Calabar flank trends in the northwest-southeast direction, which is opposed to the Benue Trough, which trends in northeast-southwest direction. However, these basins are coeval due to the sedimentation packages, while the structural alignment shows that the Benue Trough trends in northeast-southwest, while the Calabar flank trends in northwest-southeast direction. As the structural alignment within Calabar flank as a result of the Ikang Trough and the Tuhai. This led to the sedimentation package within the Calabar flank, and the first sedimentation or the sediment deposited within the Calabar flank is the Awi formation, which is the oldest formation in the Calabar flank. And this was overlain by first marine incursion in the Calabar flank, which is known as the Famosin limestone. Subsequently, this was overlaid by the second marine incursion known as Ekenpon shale, consisting dominantly of shale unit with intercalations of marl within it. The overlaying the Ekenpon shale is the new native marl, and this was subsequently terminated by Saturnian episode. There was an event, the Saturnian episode terminated this deposition. After the Saturnian episode, Nkoro shale was deposited within the Calabar flank, and after that, we had the Benin formation, which was deposited on the Nkoro formation, marking the beginning of the tertiary episode within the Calabar flank. So Calabar flank is a Cretaceous to tertiary sedimentary basin, which is from Awi formation down to the Benin formation. As we progress from this location, where we have the contact between the Awi formation and the basement contact, we will move across down to other formations, which the next formation from here is the Infamosin limestone. From there, we move to Ekenpon shale and New Natamal. That will transit from here to other formations, describing the various formations within the Calabar flank. Thank you.
Thank you. Thank you. Let me play the next video.
So, hi viewers.
So let me know if you can see a second video showing some ladies and gentlemen in the field.
Yes, it's up.
Okay.
Yes, we can, Doug.
So, hi viewers. Welcome again. So this is the NAPE 2025 virtual field trip, or virtual field expedition, whatever you call it. Oh yeah. But we're here to study rocks. Yeah. And we are right here at in the Calabar flank.
as we know it today. This is just to really show you a much regional introduction to this area in study. If you look to my bottom right, you do have sort of a base map that shows right there in the middle Calabar flank. So in a bigger sense, structurally, or in terms of boundaries, the Calabar flank is bounded to the north by the urban massif. And these are generally basement blocks. To the south by what is currently called the Calabar Hinge Line, beyond which you now have the Niger Delta Basin. So you have the Calabar flank, the Niger Delta Basin, as we currently have it. And then to the east, that is right outside Nigeria, it's bounded to the east by the Cameroon Volcanics. So across this boundary, you're out of Nigeria, you're in a different country, and yeah, so just so you know. And then in the western area, we have the Ikpe platform, and that's sort of what's bounding the Calabar flank to the west. And beyond that, you have other basins, the Anambra Basin, all just, adjacent to that platform. So that's in a much bigger sense. If you look at, again, we've also taken a line from northeast to southwest trend, and that's what we've shown in this upper transect here. From the northeastern area angle, we have the urban massif, basement rocks, and then you have, as you go from northeast to the southwest, you're going to progressively younger, formations. You do have the basement right here, followed by the fluvial continental sands, the Awi formation, if you're familiar with the stratigraphy of the basin. And then overlying that is what we call the Formosan limestone, and that's generally returning to shallow marine conditions or shallow water conditions. And then that's also followed by right here, right here. After which you have another return to a more shallower condition. That will be the new Netim Mal. So from Formosan limestone to the Kenkpom shale, and then returning to the new Netim Mal, is telling you something about the environment and the water depth. After that, we have a period of tectonics, which is called the Santonian tectonics, if you're very familiar with that, and that really also impacted the deposit in this basin, as well as in adjacent basin like the Anambra Basin, if you are familiar with that. And then, so after the Santonian tectonism, you now have the Mporo shale, and that is unconformably overlain by the Benin formation. These are generally continental sands, more of Paleocene to recent in age. So this is just showing you the transect, how we're going from the older basement rock from the northeast. You progress to, you have the oldest formation, sandstone in this case, dominantly fluvial, pebbly at the base, finds upwards, and then it progresses to the Formosan limestone, which generally has been observed to form on the platform as you have it within the Calabar flank. And then that progresses down to other formations like the Kenkpom shale, which, like we said, marine conditions, marine shales with all beds of marl or lime or siltstone interbedding those marine shales. And then it progresses to the new Netim Mal, which again is younger than the Kenkpom shale, after which you have a non-conformity, significant ones of Santonian age, followed by the Mporo shale, and then the Benin formation sits non-conformably on the Mporo shale. So that is the Calabar flank, sort of in summary, right? And that's what we have been looking at. And the idea here is for you to have a bigger picture view of this as you prepare for a much deeper, understanding of the different locations as we learn more as we go to the different locations.
Okay, thank you. I don't know if that was clear enough. Can anyone confirm?
Yes, it is,
I
Doc.
heard that. Okay, so this is just a way of really introducing the basin. Thanks, Dr. Romeo, for the very excellent intro. I saw a no, sir. What was that? Did someone not get it? Or maybe was the sound not okay? Okay, I hear yes now. Okay, great. So this is just a way of introducing the basin. Before we go into the different locations, right? You do know of the northeast southwest trending Jane Charcot Romanche structural trends. But one thing that is unique to Calabar flank is that it trends northwest southeast. And it's also an offshoot of that failed rift system, which happened
when South America and Africa was separating. So that's one element to keep in mind. The orientation of this Calabar flank is different. And then we also talked about the boundaries. But more importantly, as we go into this expedition, I want to think about how has the behavior of the sea level impacted the deposits within the Calabar flank, from the Awi Formation to the Formosan limestone to the Kempong shales, and then down to the New Netimal, and then to progressively younger units, the Mboro shale, which has the Santonian dolomitic unit in it. How has that impacted things? And then also think about the petroleum system elements, maturity of those shales. What could be the reservoir? Sand? Do we have limestone reservoirs? What's their quality, right? Do we have a working system? So we'll go into details of each location, but this is just for you to open up your mind and get ready for this very interesting session, which I will all be part of. Thank you. I saw a hand up. I don't know if it's a question or a comment, but yeah, let me know if it's something. Otherwise, we'll just move on to begin the real deal. Thank you.
No, I'm not sure I can see that hand.
Okay, all right. So let's move on then to the next item on agenda because of time. So yes,
Okay.
what's next? A break?
Yeah, so we have Dr. Okon chime in to this if he needs to before we go to the stop one proper.
Yeah, so I'll be sharing the link to stop one so that I'll send it to you, Tunde. So you help us put it in this meeting room and then in the, I think, the chat room also. Thanks.
Okay. So Dr. Okon don't need to chime in here, right? We'll just go straight up to the stop one.
Yeah, I think we have a break, don't we?
Yeah, we skipped that 10 minutes break. That was supposed to be a short break for 10
Okay,
minutes.
then let's go on. Let's get on
Yeah.
to question one then. That's fine. Let me send in the link.
Tunde, put it up.
Yeah, so you can share the link for only location one. I've sent it to you on WhatsApp.
Tunde, can you hear us? Please confirm you can hear us.
Yes, I can hear
Okay.
you.
And just for clarity, are you also streaming this on YouTube so that if we need to refer people there?
I am not doing that.
Okay.
You want us to do it?
Yeah,
No, it's fine.
I don't think we should. I
No.
don't know.
No.
Yeah.
So we're waiting for Tunde to put up that.
Okay, while we're waiting on Tunde, I've shared location one here. So if you're here, you can quickly click on that link and yeah, have fun with the visuals before you, and then we will now go ahead to begin the location one proper. So you can also download, if you open it up, maybe Dr. Kun, when you begin, you also show them where to download it from so that we're all on the same page before you kick off. But I think we should go on because of time though.
Yes, please.
Okay, can you see my screen now?
Yes.
Yes, we can. Yes, we
Okay.
can.
Yeah, so I think Ogatunde, you might want Dr. Okun to share because he is the one that will be driving, right?
Okay, let him share. Is he on
Yes,
the
he might be
call?
able to share his screen, so he's the one that will determine where to go and what to click on at any point in time.
Is he on the call? You can just signify so that I can promote you to a panelist if you are here.
I'm already connected.
You can raise up your hand. Okay. Just go ahead and share, Dr. Okon. Let me stop mine. Dr. Okon, you can go ahead. You have the floor. Okay, you can see your screen now, Dr. Okon.
All right, thank you very much. So once again, I would like to welcome everybody. So thank you, Dr. Ifeanyi, thank you, AIT, thank you all for taking part in this and inviting us to share our part. So I'll like to guide us through on what we are seeing on our screen are some icon on the top, which have a location map. You can see the icon location map, and then all sample location points. Then we can navigate from one point to the other using the panel by the right-hand side of our screen. Okay, so I'll try to take us through what we had discussed, the oldest formation in the Calabar Flank here. We have the Awi formation, like was first of all mentioned, sitting unconformably on the Precambrian basement rock. So as we go on, I hope that we'll have a good ride through the virtual trip to the Calabar Flank here in this chat room. Thank you very much. So if we click on that icon like we have done here, you can see what we have here. Before we continue, this shows us the
quick one, Dr. Romeo. Can you hear me? Yeah. Can you? You might want to mention that they should first maybe download the guidebook so that everybody have the material that everything that we'll be using is documented in. That's all the way to the right, the guidebook. I think we can also, maybe what I'll do is also share it with Tunde, so he will share in the chat room, Tunde or Samuel or anyone in the chat room, so that they all have it.
Okay.
Yeah.
Okay. All right. So there's a guidebook we need to download. It's on. Okay, so it's going to be shared on the chat room by Dr. Ifeanyi. So I would like to implore everyone to try and download it because it will be useful as we go through. One will really understand the progression from one stop to the next stop. Okay, so we'll just take it on from here. What we have here is we are standing on the wings of Heaven Quarry. This quarry is located somewhere within the urban massive Calabar Flank. What we see here are the crystalline basement rocks of the urban massive. These rocks are predominantly Precambrian in age, and they are, of course, much more older than the sediments that overlie them, which is Cretaceous, most especially Neocomian to Apsian in age. So what you'll be seeing as we go through this guide, I'm sure we can view the aerial extent of this work. You'll be seeing the different basement rocks and the sediment unconformably overlying them. Okay. So what we have just seen here is the area. Every participant is once you've downloaded the link, you are at liberty to navigate it, but we could guide ourselves by moving from one stop to the other so that our observations can be made from one section to the other, and then we can be guided by what we are doing and interact on whichever section it's most appropriate for us to talk about. Okay, so at this point, I'll also want to show us if we can go to the right hand side of and look at stop 1A. Okay, so that's where we are. What we have here okay, so now this is stop 1B. As discussed, you look, if you can see with me, there is a photograph here that shows us a close-up of the basement rocks on the line, and then the sediment overlying it. So if you have it on your section and you click on the first, yeah, the first stop there, you see the basement rocks and then the sediments overlying it where it's already overtake where my mouse, I don't know if you can see the pointer going around there. These are the directions here. Okay, so the next to it is showing you the basement rocks on the line, and then the sedimentary basins, the sedimentary formation unconformably overlying this crystalline basement rock. So these are Precambrian in age, and these are Aptian predominantly in age. So that tells you that there is a time gap on this surface here, and this time gap is represented by an unconformity surface. All right, so that's it. So you move from one section of this, it takes you around the whole area. So we could also do that. You are guided. I would want to be sure that we can all see this particular location that we are looking at from our ends, having downloaded the link. We move from one section to the other. If you can pan through with your mouse just the way I'm doing, you'll be seeing the various stops where we actually visited there. So next to that is the stop 2B. So if you click on stop 2B, it will take you round again into the section of still the same quarry, but you still have other close-up views of the sediment basement contact. Okay, we can all do this on our screen. Yeah, so you see what you have here are inclined crystalline rocks, and then the segments of their formation unconformably overlying. So that's the beauty of what we have here within the Calabar plan. And then we can move from one of these to the other. I would like to I entertain comments from participants on how how clear and how interesting they have found this navigation through their information. So this is also at sub 4. Sub 4 shows again, if you can look closely, you see some fractures and displacement that might indicate faulted section. And then what you see here is the segments are taken away to have access to the purpose of this quarry to get the crystalline rock. But then again, it's a good, useful illustration we can have to see the locations of crystalline basement complex. Okay, so this is a close-up shot which we have projected here that shows the basement complex underneath and the sedimentary formation overlying the basement rock. Okay, so the next close-up, we may want to look at the next one, which displays clearly that there is some sort of displacement here, and then it's worthy of note that these have very structures that are crossing from the basement, sometimes extend into the sediment. It will now give you an idea about age relationships between either the younger sedimentary rocks and the older basement. Howbeit, if it crosses or terminates before the sediment, what do you expect to see there? What are you going to interpret that as? If it continues into the base, into the sediment, well, how are you going to tell the age relationship between the faulted rock and what you are seeing? So these are the different features and structural examinations we will want you to look at. And bear in mind that at the end of this, there are some activities that we ought to do. And as we go through these, our minds should be open and be guided so that we will be able to take part well in the exercises that are coming after this. This is another close-up shot. Like I said, once you click the icon there, you'll be able to navigate through the different sections on this. So one can also zoom it in and zoom it out and get a good perspective of the image that we have here. All right, so I'll run up to step 5B. And yes, voila, this is where we are. So you can pan the sections and you see yourself around the various parts of the quarry that exposes the crystalline rock underneath and the sedimentary formation of the sedimentary formation directly overlying it, albeit non-conformable. Okay. All right. And fine. Last but not, so we can see a different section of the photos that and relics of the different areas we've gone through on this particular view, and then that's an aerial view of the quarry showing the basement rocks from the sedimentary rock line. Yeah. So, and then we'll want to end with I don't know the video, Dr. Ifeanyi, right now to be played.
I think you can play the video on your end, the one in the app itself.
Okay, so at the end of this,
the introductory video, yes, okay.
Yes, I will take the introductory video. So we just hear something. So we're on that now.
Okay, maybe let me play it from this end. I have it not in the app. So, because it looks like this one is breaking up.
Okay, so we'll watch it.
Okay.
Okay, good morning, everybody.
Please confirm if you can see the video of the gentleman with the white cap.
Yes, we can.
Okay, I'm going to play it now.
Okay, good morning, everybody. I am Dr. Emmanuel Okon, University of Calabar, Department of Geology. So I would like to welcome you to the Calabar flank. Where we are now is actually the Awi Formation, where it sits unconformably on the basement complex of the urban massif. So what we'll be seeing as we look through is the continental deposit, mostly fluvial marine. What you expect to see that the grains or the sediments are immature. You see some conglomerates sitting towards the basal part of the Awi Formation, as we'll see when we zoom closer. And then you see several cycles. What characterizes the Awi Formation is several cycles of finding upward successions. You see them clearly where you see the conglomerates at the base, the medium to quartz grain sands that are cross bedded. And then as you move up, you start seeing your floodplain facies that are flacer bedded, and some, even to some extent, coaly. You see some lignitic bands. So these are what you see characterized in the formation as we zoom closer. And you see that these occur in cycles, a cycle after the other, and all of them are showing typical fine upward succession. Many people have ascribed the model to a meandering system because of the flacer bed. Some people have said it's actually fluvial marine, but all these would see it as we go along their formation. Again, what you observe here is that the contact is sharp, and then the underlying basement rock is showing some angular relationship. So definitely that's some sort of unconformity, the first unconformity in the Calabar flank, like you would see. All right. Thank you.
All right, thank you. Thanks, Doc. And for those who sound are not coming out right, yeah, it might just be network. But I hope that this was a sort of a great introduction. Let me just very quickly go to a slide that I want to share. Okay, not this one yet. So if you notice, let me know if you're seeing a slide, if a PowerPoint slide with the stratigraphic column.
Yes, we can.
Okay, great. So if you notice, we started at the bottom. So for this expedition, it's going to be from bottoms up, right? So we're starting from the oldest Precambrian basement rock, which the doc has, graciously given you the details of the subregional story, as well as how it relates to the overlying sedimentary formations, the Awi Formation being the oldest. So the next one we're going to be seeing will be within the Awi Formation, and then a bit of basement also in that location. And then that will be the flow all the way up to the last formation. The good thing is, for this field trip, we went through every of these formations. We saw the Awi, the Famosin, the Kempom. You will see each of these as we go on. Okay. I do have a very quick teaser for you. This is sort of breakfast. Okay. So we will just need individuals to quickly indicate, either you use a chat box or you raise up your hand so that we want to hear one or two persons speak. What is this kind of unconformity, or rather, what kind of unconformity is surface X? And then we are also saying that the basal portion of the Cretaceous Awi Formation are texturally and mineralogically mature. Prove me right or wrong. I dare you. Prove me right or wrong. Someone. Anyone. Thank you. Okay, I'm seeing responses. And today you might want to just select someone to speak. Let's hear one or two voices. I see nonconformity. I see nonconformity. I see angular nonconformity. That is very interesting. Interesting. Disconformity, very interesting. And nonconformity, very interesting. So let's hear one or two voices, and then we'll wrap it up, and then we'll talk about the next one. Tunde.
Anybody?
I can even do that.
Yeah, you can do that. That's great. That's fine. So choose anyone.
Okay. Okay. Abba Sulema, you can unmute yourself and
Okay. Good morning, all.
Hey, hey, Abba, good morning, everyone. So, but we don't want the professors telling us these answers. Professors, apologies. We just want you to stay back a little bit, and the doctors.
Abba
So, Abba,
is
go
a
ahead.
student. Let him go ahead.
Okay.
yes.
Okay, thank you, sir. This is non-conformity. One of the reasons is when you have basement rock overlain by a sedimentary rock, in that type of situation, you are dealing with a non-conformity.
Thank you. I think I will always say the ayes have it even before I ask for ayes or nays, but most people have said non-conformity. Yeah, non-conformity. So that's it. If it is disconformity, that one is a different type where you have two stratigraphic layers parallel to each other and you have some break in records. And then angular conformity is a different kind where the underlying bed and the overlying bed, the one below is at an angle to the overlying one, which will be more subparallel to parallel. But in this case, the primary thing is that there are different types. The one below is a basement rock, whether igneous or sedimentary. The one above is sedimentary. So that's non-conformity. And then do you want to brace the second question? You want to brace a response or any other person? You can also type in your response. So the answer here is non-conformity. Okay, I see immature, false. Okay. Okay, let's take one false and one. Let's take one false and one true. Let's hear both sides. So AIC, yeah. You can select one person that said false and one person that said true, and then let's talk. The question is, the basal portion of the Cretaceous Ice formation are texturally and mineralogically mature. That's what I am proposing. True or false? Okay, anyone?
Yes, so where's the hand? Please ask to be on mute. That also makes it faster. You could just click on that, then I could just pick you up.
Good morning, sir.
Yeah. Go ahead.
Okay, yes. Thank you for meeting me. Okay, so they are texturally immature. So the answer to that is false. And that's because their textures, they are poorly sorted. That's at the basal portion, which contains conglomerates. So that shows that it's texturally immature. Therefore, the mineralogically immature, it contains a high feldspar content, which shows that they are mineralogically.
Okay, is it my network or we can't hear you again?
No, I think his network.
Okay, please indicate your name and your school. It's time to show them who you are, what stuff you're made of, what school you're from. So tell us where you're from and your school real quickly before you respond. But I think I hear that response, and I've also seen some very senior friends putting their responses there. Anybody saying through? Do we want to? You want to speak? If you think it's true, if you think that these are mature, so let's hear you, Aminu.
So I said something. I don't know if you heard that, sir.
Yeah, we heard you largely, and I think we get the message. You said false. They are not mature. That's your view.
Yes,
Thank
and
you.
There are some people saying true. Let's hear from them.
Yes, let's hear from the true.
Chukuma, Ifeanyi. Oh.
Okay, Chukuma, they called your name. Could you unmute? I think we need more admins to help out with the approvals.
Yeah, Marietta, where are you?
I think everyone in the panelist chat room can also unmute. And Samuel is here too.
Okay, so let's have Ola.
Okay, sir. Thank you, sir. So I said that the answer to that is false, that they are texturally and mineralogically immature. And that's
Okay, so
because for the texture, the basal part is conglomerate.
we
And
want to hear it true. We want to hear it true. So your false is aligning with what the previous speaker said. We want to hear,
okay.
yes, we want to hear it true. Somebody who said it's true. Let's hear them.
So if you say it's true in the chat room, you need to raise up your hand so that we can be able to unmute you, right?
Okay, Chukuma Henry says to unmute him.
Okay, Chukuma, go ahead.
Okay, my name is Chukuma Henry from Novena University, Ogume. Okay, so I think the question is true because when we talk about texture maturity,
No,
it's
hold
when
on. We're not
okay.
saying that the question is true. The question is saying, do you think, do you agree
Okay, I
that the
think
basal portion, do you agree or disagree? Are you saying it is true?
I agree that it's true.
You agree that these are texturally mature. Okay, so let's hear you. Why?
Yeah, because when we talk about textural maturity, it's when the formation is sorted. The grain sizes are sorted accordingly. And then in the Awi formation, the textures are sorted accordingly. And then when we talk about the mineralogical maturity also, it's when the stable minerals are on top of the unstable minerals. Like we have the quartz up against the feldspar.
Okay, that's your explanation.
Yes, sir.
Okay. Okay, I think I'll just maybe go ahead and just a bit of I have a blank screen. Let me know if you can see it.
Okay.
Yes, you can. Can anyone see? Okay, you can see it. So this is the basement, right? And things happen uphill, and then everything begins to move down the hill, and then you have some distal location where you have something that looks like you're going to the ocean. So erosion or denudation happens at the uphill area. And then parts of these rocks, which we've seen, you saw what Dr. Okun showed, right? You have some sort of falls at the crystal part of it, probably at the top of it, because of stress release, because of quarrying activities of men. What that causes is that you now have portions of this rock breaking away and finding their way either in large masses as boulders or whatever form, and they find their way eventually moving away from the host rock, from the parent. You may have heard of the word provenance. So what this is saying is, as this mass of rock, right, which is a basement, as it's weathered and it moves away from where it's originally at, something happens to its texture. Texture will be referring to the grain size, the grain sorting, the angle of the grains. Some of them you might have seen rounded shape, not so rounded, angular, subangular, all kinds of nomenclatures, right? And then you also talk about the clay contents, right? The clay contents, those unstable minerals, the feldspars. As it goes further away from the source, do we agree or disagree that some of these components will not be the same? For example, if it is this shape at point A, by the time it gets to point C, it is likely to have a better shape that looks more rounded, not well rounded, but better rounded, less angular, basically. Is that a fair point to make? Is that a fair point to make? Okay. And then what that means is that the quartz components are the ones that will survive the distance traveled, right? The quartz content of this rock will survive it. So when you see a component in the bottom of, let's say, or close to an uphill basement structure like this, they are very close to source. They haven't traveled a lot of distance. What that means is that the quartz is there, the feldspar is there, and of course, you have rock fragments, right? They are still in place. As it travels further away, as you go from Sokoto, you're coming down through Abuja by foot, on foot, and you're trying to make your way all the way down to Lagos.
Do we all agree that your textural makeup, your foot will have a different orientation or different
Oh,
feel
yeah.
by the time you've done that distance? That is what these rocks go through. It is only the strong-minded that will make it on foot from that distance and still retain and still be standing by the time they get to Ogun State or Lagos. In other words, the likes of the quartz will make it from point A to point C and will still remain. And all those rough edges you see for the rock that is uphill or at point A, by the time it gets down to point C, because it's transported downslope, it's moving through the streams, through the rivers, all these rough edges will have been broken off. The rounding will be better, to be better rounded. The sorting will be better, of course, there will be better sorting. The clay minerals that are unstable they won't survive a little erosion because they will have dissolved and moved on. Which now takes us to the question of textural maturity and mineralogical maturity. So the rock that is at point A, that is closer to source, will be more texturally immature because it ain't seen nothing. The angles are still there, it hasn't moved. The unstable minerals, right, are still there. The quartz, the feldspar components, the autogenic, they are still there. So they are still in place, so they are immature. But the rock that has gone from point A to point C has seen life, has seen erosion, has seen chemical changes, has seen all kinds of activities that will make it better rounded, better sorted. The unstable minerals will have found their way out. Hence, you can say it is more mature if it is further downslope away from the source. These rocks that we just saw at the Away Formation are sitting right at the point where they were just born. So I think you will agree with me that it is very, very safer to say that they are very or most likely immature as opposed to mature because they are just at the point of where they were made and they haven't really gone through any significant erosion. I don't know if we can all be on the same page on this very one, if it is possible. Can I see a yes? Can I see a hands up? Can I see something to indicate that before we move on so that we're all on the same page? Because it's going to get more fun. This is just the beginning. I thought to just spend a little more time to do this. Do I get an endorsement to move on?
Yeah,
Okay.
please move on.
Thanks, everyone. Okay, so let's move on to the next location. Thanks. AEIC. Yes, let's move on.
Yes.
Apologies, I took a long time because this is just the beginning of it. The subsequent ones will be less invasive, I think.
So it will only get interesting if we get ourselves in the mood with this, right? So don't be afraid. There is no wrong answer here. We're here to learn, especially for the students that are amongst us, which is quite a number. Feel free to chime in. Don't be shy, all right? You'll be doing yourself a favor when you do that. So I think next on our list is there's location 2, stop 2. Stop 2. Yes, please. Dr. Okon?
Okay, here we are again. This location is still within the formation, but the difference where we have the start point of the Lagos Calabar Coastal Highway. So again, we'll try to start like what we see on our screen. We're all guided by the location map.
Yeah, the sound is not very great, Doc.
So can you hear me now?
I can hear you though, yeah.
Okay. Well, is it clear now?
It might be better, Doc. Maybe we want to start with the video before.
Okay.
Yeah.
Okay.
The video
So,
is basically, yeah.
I'll start with the video, so we'll now follow through with that. Okay.
Yeah, if you need me to play them, yeah.
Okay, you can help me play them from your end, so I'll take it over from there.
Okay.
Is Dr. Ifeanyi helping you to share from his end? Okay.
Yes, I'm sharing now. Let me know when it's up.
It's up.
Up? Is it up yet?
Yes.
Okay.
Yes, you can see it.
Hi, viewers. Good day to you. My name is Ifeanyi Chukwuobi. So this is the NAPE 2025 VFT team. We are currently at the Lagos-Calabar Expressway. This is actually the beginning of the Lagos-Calabar Expressway. We are at a road cut where we have very beautiful exposures of the boundary between the underlying urban massive basements and the overlying sedimentary formations in the Calabar flank. So what you will see here will be metamorphic rocks at the bottom. These gray units are largely metamorphic rocks. And then you see some light banded units, which we have interpreted to be more of igneous, pegmatitic intrusions into this host metamorphic rock. And then right above that, you will see what looks like some kind of sharp boundary, right? That brownish section there. That is the boundary between the underlying basement and the overlying sedimentary formation. So we have the basement complex right here, some igneous intrusions right in the middle, and then you have the overlying Awi formation sitting unconformably on the underlying basement rock. So what you also notice as you go on this expedition will be that the Awi formation has got, at the bottom part, you will see some pebbly units, largely made up of clasts, right? Well, a lot of work has been done to determine whether this is of fluvial origin. I leave that to your discretion to make that call. But you will observe that there are mostly, in this area, unidirectional signatures. Sometimes, largely, you see a lot of, finding upward, of course, finding upward signatures, pebbly units at the bottom that grades into finer units at the top, and then the system is repeated, right? So that's the key thing. And one thing I'd like you to also think of as a reservoir, for those of you who are reservoir geologists here, as you focus on the sedimentary component of this Awi formation, think about the impact of, the sorting types, the textural and mineralogical maturity. Well, how does that impact your reservoir quality? Okay. You have different grain sizes, pebbly units, smaller, finer units, and a lot of acoustic components or feldspathic components that tells you that this sedimentary component is closer to source and is texturally and mineralogically immature. So what that means is that if I'm, as a reservoir geologist, think about how that influences your porosity and your permeability distribution, connectivity between one part of the reservoir to the other, and ultimately, if you're doing your volume assessment, how does it all fit? So as you go on this expedition, I want you to have an open mind, make observations, come up with scenario-based interpretations, and let's see how this goes. Do have a good time, and well done. Thank you very much.
All right, thanks. Thanks. Dr. Okon, you can go ahead.
Okay, so while we prepare to share it, maybe you want to put up the link for location 2 on the chat.
Okay. I sent that to Tunde. I thought he was going to share the link one after the other. Okay, let me just also do that too. Tunde, if you can help, real time, when we get to a new location, just share the link for that location just before we start it. Okay. You can go ahead, Dr. Okon. I will be sharing the second location link now.
Okay. So thank you, Dr. Ifeanyi, for that overview of this particular location. So while we wait for Pascal to get it, I would like to take us slowly through this particular location 2. So we start by clicking on the icon where it starts, and then we navigate through. So what we have here is the aerial view of the excavations that defines the town highway. And then here at Block 1, we have the Awi formation sitting on the basement complex. See here. So if Dr. Ifeanyi had mentioned to us that you see the metamorphic basement complex rocks of the metamorphic basement included by pegmatite. And then what you have here are snapshots that flows into the different lithologies. So you can attempt to zoom in and see the different what he has mentioned, where you have finding upwards of questions in each of the photographs you have here, and then any of the icons you click will show you the sedimentary unit directly overlying the basement. So again, it is important to see that non-conformity, almost approximating these ion stained layers directly underlain by the crystalline basement rock. And then we'll see in the next photograph where you have, okay, so this is the basement complex rock, and this is what marks the contact between the segment and the basement rocks. And if you look, zoom it closely, you see some sort of less gang rings close to the contact point, and then it's seeing pebbly material within the sandstone, quartz grain sandstone, as it begins to fine as you move upward. So these are characteristics of the Abu formation. Then it's also characterized by unidirectional flow segmental structures, your rock cross bed, and these are the points you need to pick while you log the section upward. One expects that as you go from one section to the other, you're able to take note of what exactly you see on that floor, because it will be instructive when it comes to the point of interpretation. So location 2, here we are. So again, I expect that by now we're able to have the link and we've downloaded it. It will be fun if we can, follow through on our own end using the link as provided here. So what we want to see is at this point where we are, the dark gray unit here, the placer bedded mud rock, which is the top of the first cycle of finding upward progression. So directly above it is starting some pebbles, and the cycle repeats itself again. Okay, so these are typical of the Abu formation. What you have, if you see clearly, like the clasps are sub-rounded in some cases, sub-angular. That points to the fact that the distance from its provenance is not so much. And then where you have very large clasps like this and fine clasps, it tells you a lot about the sorting of the sediment. They are not all of equal sizes, so they are quality. Okay, so we go on to the third point, top two, position 2. So, okay, that's what we have here, and the fourth point. So at this point, we have the opportunity of seeing a large extent of our formation. Like we mentioned, this is the root cause that was graciously exposed because of the construction of the coastal highway. So the beauty of this DFT is that we are seeing this as it is in its majesty. Before long, we may not have the opportunity to see it the way it is now. It's good we take the best of opportunities we have to really study and archive it in our annals. So again, there's so much to see in top 5. here we are. So if you look closely, you can see what looks like changes in coloration, here. The texture. The texture of the rocks are different. Quartz material, the bottom is fine of water fine of water segment. All are plastic sandstones and maybe conglomerated towards the base. So these are typically what you see across the information. Okay, so this is the plan view of where we just discussed. Basically, it gets clearer. It's just if you're able to zoom it in, you help. You see that the quartz materials are underneath, and in some cases you may be
Yeah,
able to
Dr. Okon, your sound is not clear. I think it's not clear from my end. Generally, it's been poor sound, and I think it's not just me. You might want to, I don't know, you might need a headset or something, or maybe this. You want to maybe check the connection. Yeah. Is it possible you use a different system if it is better? Like AEIC's system is clearer whenever he speaks. So whatever works. So while we're waiting for that change, I just want to check in the room. How's the experience been? Or rather, are we able to individually use the link to do the navigation, just like the instructor is doing? I like a confirmation. The link has been shared. Are you able to just, go around? Because more importantly, beyond the technology component, which is going around, there is a connection. These are locations that is fast evolving, and we're trying our best to document these things in a way that it's there forever. We don't lose it. So this is just a way of helping you get to the field while you are in your comfort zone. Since we can't take everybody, we can't take 153 people to the field, right? So let us know, and of course, this will always get better, can only get better. Yep, thanks, Pascal, Abigail, et al. For confirming. Dr. Okon, if you're ready, just let me know so that the sound, they can also get the correct feel for what you're saying.
Okay, he's logging in. He's
Okay.
he'll be
Your voice
talking
is
now.
clear. So I want that. I know you're in similar location, so
Yes.
we want it, copy and paste that voice and let's replicate it.
Yes.
Yeah. Yeah. And by the way, everyone, this is not a lecture. So just so you know, if you have a
Correct.
comment, if you have a question, let us know. And this is field work. It's not going to be all rosy. So please, yeah.
Yes, go ahead, Dr. Romeo, Dr. Okon. He's moving in here to just speak from here. It's just that he may not be able to navigate. Over to you.
Okay, so I would like to continue from where we are. Again, this is the final section of the coastal highway. What we appreciate here is that you see a thick pile. Okay, so what we have here is Don't just.
Yeah, so Dr. Okon, I think, trust me, everyone is doing the same thing. So you may not even need to wait on your own to show up. Just they all have the link. They just tell them to go a certain location since you already know what is there, and then you can blast off. They don't have to really listen, follow as yours is coming up because they have the same link and they're doing the same thing. And they can even do other things different from what you're doing.
Okay, I
Okay, I
believe
believe you can hear me now.
Yes, I can hear you. It's
Okay.
echo you do. Yeah, maybe one person will have to mute.
Okay, great.
Okay, this is perfect.
Okay, so what we have here is stop 2, what we'll regard as location 6. So again, what we are displaying here is the section of the Awi formation sitting on the basement. Like we mentioned again, finding upward succession, multiple cycles. We have trough cross beds at the medium to coarse grained sandstone. Underlying that, we have a pebbly sandstone sitting on the basement. So you see that that cycle continues and terminates where we have the placer bedded sandstone, mud rock that probably would want to characterize floodplain deposits. So that cycle continues again. And one would say if among these different facies, which one will best approximate a good reservoir system? How do you expect that reservoir to look like? For instance, if you are trying to look for the best locations to find reservoir rocks within the Calabar Flat, these are things that should stay within our mindset as we go through from this location to the next. So we are going to look at one more video before we end this particular location. Okay, so this video is showing us sections of the basement rock. What you have here are crystalline rocks intruded by feldspathic material. Okay. And this shows from this unit here upward shows the Awi formation. All these sediments of the Awi formation sitting on this exposed section of the basement. So thank you. Dr. Ifeanyi.
Okay, yeah, thanks, Prof. Thank you for this one also. Very quick activity. We'll just quickly look at it. Let me open the page that has got that activity. So get ready for fun time. Get ready again. Give me a second. So we are still in this location two, right? So the star here, if I'm sharing my screen, let me know if when that pops up, it's right in the Awi formation. So if I'm going to adjust it, I'm going to move up just a little bit because we are in the Awi formation, but we also see some elements of the basement below it, more like meta sediments, right? Metamorphic rock with igneous intrusions, but largely is sedimentary because of the Awi formation we just saw. So now a bit of a puzzle, a bit of a teaser here. I got this section, and we already sent this in the chat room. So I like any attempts, or I don't know if anyone has done this, we're willing to share, or you want to real time do it now, given a few minutes. First question is just to draw a little log. You know, we all field geologists to do that. Let's see what you've got. You probably already have seen that, but then still just try. Let's see. Second question will be looking at the different sections of this rock, just hypothetically, 1, 2, 3, 4, 5, and 6, different, we call them different facies, right? Which of them will have better reservoir quality? And now this is not saying it's cast in stone, it's just saying, hypothetically, what do you think? Let's have a discussion around reservoir quality. Where do you think you have a better one? And then thinking of fluid flow, what do you think, which do you think will have a better direction of continuity? Do you think things will flow more vertically or more laterally? Again, this is also for us who do a lot of subsurface work, where you think about connectivity, you think about flow baffles and barriers. You want to put in a well, you're thinking, how will my fluids flow, in what direction? You know, with a section like this will give you a picture perspective of how things can be in the subsurface. So yeah, let's hear if anyone's got and you want to make an attempt or you want to share, let us know. We already sent this in the chat room earlier, so let's know if you're able to take a look and you got something to share. Or you want to verbalize your answer, that's also fine. We got 5 minutes. You can also use the chat room. So put your answer in an order, 1, A, B, C. So A, well, A is just a sketch, so you can respond to that by text. And then B and C, you can share. Let's get to share our thoughts on C. If there's any hand raised, let us know. Any of the admins will unmute you. Does anyone have a log to share? Okay, I see a hand raised. Samuel or anyone, please unmute. Unmute the person.
Okay, good morning, everyone.
Good morning, we can hear you.
My name is Dennis Solomon. I'm a student for the Federal University of Technology in Mina. Okay, I want to give answer to number B, the B part, which says from your observation, which facies want to see likely to have better reservoir quality. And if I were to say, I would say facies 1. Now, reason being that facies 1, it is possible, it has higher porosity and permeability. Yeah, so that's my first reason. And even if you observe from facies 1, it's definitely is not going to have more cementation. So what do I mean by that? The other facies, that's 2, 3, 4, and 5. Since facies 1 is lying over them, definitely they are going to have more cementation. So with this viewpoint, I believe facies 1 should have a more reservoir quality. They should be able to contain and sustain liquid. So that's my own point of view. Thank you.
Thank you for that. Any other thoughts? Thank you for sharing that very detailed explanation also. And I see some text, messaging the text. So a lot of reaction, and this is exactly what we want, right? So people are not asleep, right? So 1 and 2 has better reservoir quality, 1C, and then, okay, I also see people are responding to the C question that says, is it vertical or lateral? So we are saying that there will be more connectivity laterally. Okay, that's what majority, almost everyone is saying. And then, okay, more responses. Fascists 1 and 2 will have better reservoir. 2, 3, 4. Okay, 1 and 3 have better. Okay, I think we largely have gotten some good responses here. And then Pascal Igwebi say, yeah, laterally because vertical will be interrupted by non-conformity. And okay, that's fine. All right, so let's get one more audio response, and then we'll probably look at the class solution. Yeah, lateral continuity. Yeah, admin, unmute someone. Okay, no hand.
See 2 hand up.
Yeah,
Abdul
just admit both of
Mahid.
them so anybody can speak.
Abdul
Yeah.
Mahid, go ahead.
Hello. Hello, good morning.
Good morning, Abdul
Hello.
Mahid. We can hear you.
Hello, can you hear me?
Yes.
Yeah, so I want to answer maybe even all, especially the C part. It's obvious. It's lateral continuity which is better than vertical. So it's going to continue laterally because the sandstone beds provide better lateral flow pathway. Then for the B, the best reservoir quality will be at the second fascia level, which has more coarse, well-sorted cross-bedded sandstones. I think that one will have better reservoir quality. And there's a possibility of weathered and fractured rocks, in fascia 5. But I think it will have better reservoir quality in the second fascia. Then for the lithology, I think fascia 1 has a thin and pale fine stone with silt. Then fascia 2, yellow, it has yellowish and thicker cross-bedded. It's mostly coarse sandstone too. Then in fascia 3, it has sandstone with it's interbedded with, mud with a little bit of mud. Then fascia 4 has thick dark mud with shell with it. It should be that, yes, thick. It's thick. Then fascia 5, the gray, it has gray from the color, it's a bit gray, and there's massive fracture, which may be caused as a result of weathering. Then the fascia 6, that is the last one, which is the basement. This is the basement, mostly crystal and rocks. This should have a very low permeability. Yeah, that's all. Thank you.
Thank you very much. That was very professorial, and thanks for systematically chronicling your details. And I really appreciate that, really going through all of them. Thank you very much, sir. Let's hear from Ms. Omaagu. We do have some time. I think anybody that raised their hand, we can just unmute them in advance or give them the capacity to unmute when they are ready. Agu, you ready?
Good morning, sirs.
Good morning,
My name
Agu.
is Agumesoma Miracle from Ebonyi State University. And I'll be answering the B part. The phases with better reservoir quantity is fascia 1 and 2. Reason being that reservoir quantity depends on porosity and permeability. And the fascia 1 and 2, which is the upper coarse to medium grain sandstones, are likely to have better reservoir quantity because they are more porous and permeable, and they are less cemented together, and they are likely to store fluids effectively. So that is my own opinion, sir.
Great. Thank you for sharing your opinion, and very well delivered also. Thank you very much for everyone. I think I've seen all the reactions. What I'm even testing here is it's just I want someone to tell me why it is probably Fishes 4 that is the best, and give me a scenario that is plausible, that is possible, or Fishes 3, or even Fishes 6. I like to see out of the box proposals like that, because truth is that is what we do as subsurface or surface scientists. We try to model all possible scenarios, of course, as much as possible. That is something that is, defendable technically. So yeah, let's take Nelly. Nelly, go ahead. Just unmute them. Let's just get them, give them capability to talk. AES, help me with time check also to be sure we're doing good on time.
Lenny, go ahead.
Okay.
I've asked her to unmute.
Yeah, you can mute everybody who raises their hand so that they can speak when they want.
Lenny, can you hear us?
Or any other person who's ready.
Okay.
Yeah.
Good morning.
Okay.
My name is Abdulhamid Saleh. I'm from University of Maiduguri. I will still keep to my argument. I believe Fashi 2 will be better because of the sandstone and the cross bedding, and it has high porosity and permeability. So, and I think that's one of the things we look into when we are looking for, the reservoir quality.
Okay. All right. So any other view? Yeah, we can hear you. We heard you.
I think is
Hello?
3 and
Yes, we heard you. Yeah, Abdul. Thank you very much.
I think
Okay.
it's 3 and 4.
Okay, 3 and 4. Okay.
Because in the course of the lecture, we were told that they are finding upward. Definitely, Fashi 3 and 4 are more porous than Fashi 1 and 2. And it depends on porosity and permeability. So I guess it's 3 and 4.
Okay, thank you. Let's take Lawrence.
Okay, sir. My name is Lawrence Blessing from Ekiti State University. So even if these Fashes 1 and 2, they can be more porous and permeable than Fashes 4, but I will still go for the Fashes 4 because for a reservoir to be complete, we still have to have the trapping mechanism. And this unconformity lying above the Fashes 4 can serve as the unconformity to prevent the hydrocarbon from escaping. So I'll go for the Fashes 4.
So you're thinking of oil already. You want your oil preserved.
Oh, yes.
You're not just thinking sand. If I'm a recruiter, I'll keep you in mind because you're thinking of the bigger picture, not just sand, but this one has got something to keep the oil in place, All right, well done. Phillips, please.
Yes, good morning, Mr. Ifine.
Yes,
what determines porosity and permeability has to do with grain sizes. In areas where you have the larger grains, intertwine with the smaller grains fall to clog the pore spaces that is there. So in area where you have arrangement of like in Fashi 2, where you have the arrangement of the grain almost at equal sizes, they create a lot of pore spaces for the fluid to occupy. And also you see there that they lack a lot of silt that may have clogged the interconnection between those pore spaces. So I think Fashi 2, we have a better reservoir quality in terms of porosity and permeability. Thank you.
Thank you very much. Ebube.
So, question B, I think Fashi 4 is the best Fashi for the reservoir because
Okay. Okay, your sound is cracking up. After you will take one more, and then we'll wrap up this session. Your sound is cracking up. Okay, Moshud, let's hear you. It looks like the sound is cracking up. I don't know why. Moshud, can you go ahead?
Yeah, Dr. Ifan, there are quite a number of comments too in the chat box, right?
Oh, yes. After this, we'll go to the comment. Moshud,
Sir,
yeah. Go ahead.
The Fashi 2 and 1, we have good reservoir quality because as we have explained to us earlier, said that the place whereby the sediments overlaying the basement, they have it's immature and that at the point because of the phosphor and the course is also present there, and the grain size is not well sorted. That is, which can lead to which can reside the migration of the fluid within the reservoir. That means the Fashi 2 and the Fashi 1, they have good porosity and also the permeability, which can
okay,
which can serve as a good reservoir.
All right. So that's thank you very much for also sharing that perspective. Maybe I'll just go ahead with the charts and then I'll also now try to wrap up. Yeah, great conversations, and I sort of let this open so that we let more people talk, and then for those who are not talking, they're also listening in. You will very soon also realize that sometimes these answers will now become it depends. Like most of us subsurface will say it depends on the scenario you're playing, and sometimes it's not one value, it's a range of values, right? And more importantly, the descriptions I'm seeing, Nelly says Fascist 4 is a good reservoir. It has a seal or cap to stop the flow, making a case for not just reservoir, but what can keep the hydrocarbon in place. And then other descriptions are also there. Plura says the lithology of 3 and 4, but the sandstone rich section will have better reservoir. So I like these descriptive representations, really interesting. And then when it comes to connectivity, same thing. So these are really great responses. And just one more thing before I go into maybe what might be a response or class response. I'm sketching something. When you have different grain sizes like this, and then you have smaller ones as fines in the middle, maybe much smaller ones, poorly sorted. So this is like a poorly sorted system, right? Where you have the fines plugging in all the holes in there. The finer ones, the clay contents, the very fine sands are just there to plug in all the holes, right? And then you have another scenario where you have almost well sorted, meaning their grain sizes are about the same. Okay, so what the reservoir geologists, the engineers have noticed is that the better the sorting, the better the average porosity. Because if it is poorly sorted, all those fines will act as plugs, making that an overall poor reservoir, right? But if it's well sorted, meaning the grain sizes are uniform or close to the same size, and especially if it is rounded or so, right, in terms of the geometry of the grains, the reservoir quality is generally better. And then also in another system, if you have like a system where you have some, let's call it sigmoidal crossbed, or or generally let's just say crossbeds. Most times you have this is all sand, right? And this is all sand. Many times you have what we call clay on these faucet planes. So this is like a clay draped faucet plane. So these faucet planes actually sometimes act as baffles. They may not be barriers, but they act as baffles. Why? Because those are periods of like a slack water conditions. If for those of you who are familiar with tidal or fluvial systems, periods where there was quietness or low energy in the flow system, and what you have are mostly muds or fines or clay clay rocks. Those will now actually be the rocks that will sort of layer themselves on these faucet planes, therefore making these faucet planes sometimes baffles to flow. So generally, we'll prefer the one that has either it's bioturbated, that will help open up this connectivity. Bioturbations will come in if you see burrows and all of that. But if it's less bioturbated, it becomes difficult to have connectivity across baffles like this. So keep that in mind. The sorting is one element that can make porosity or reservoir quality poor. And then how much of clay do you have and how are they arranged? Are they along planes that could be baffles or that could may even be barriers? You know, it all counts. And then you now think about other things, you know, like weathering that can cause some of the rocks to dissolve and you now fill up the pore spaces. It all counts. And then if you're thinking also of porosity, depth is also an element. Sometimes what the geophysicist has really found is that at about the same depth range, porosity is about the same most times. It is permeability that could be different because of flow between one mini compartment to the other, which might be impacted by mud or clay or some of those small baffles or barriers. But porosity may not really change except you're going to much deeper depth or there's a significant difference in depth. Okay, so that's just to give us one perspective of this also. If I go to the next slide, let me know if you can see that. Let me know if you can see that it has a log. Can anyone see the slide? Any confirmation?
Yes, we can. Yes, we can.
Okay. So we have the lethal log. You may have seen that if you've downloaded the material, which is also in the chat room. So for location 2, the lethal log is this is just an example of the lethal log, a schematic of it. I know I heard people say finding upwards, pebbly at the base. That is very spot on. So thank you for your responses also, everyone. You also very rightly observe the difference, the boundary between the basements, which is largely igneous with metamorphic with igneous intrusions, right? And then sedimentary. But then our question on connectivity and quality was focused on the sedimentary facies. So if I'm to quickly sketch what I think might be something I observe or want to observe, right? You see something like this. Let me use a different color this time, maybe pink. You will see that, okay, I'm going to say we have one here, one band here, one geobody here, maybe another geobody there, like this on orange. Okay, maybe another geobody in blue, somewhere around here. Right? Maybe another one in green here, somewhere around here, right? And then maybe one more, in another sort of purple, which is fishes 4, right? So, I mean, this is just trying to say at face value, we're not touching the rocks, we're just looking at it, right? They look different. And then I get a lot of response, which is also very commendable. A lot of people have said fascists 1 and 2, great, 3 and 4, very great also. 1 and 2, because you see that they look better in terms of grain size, they look more uniform. 2 also looks more uniform. That's the green geobody. And then 3, coarser materials, looks classic finding upwards textural motif, which looks like you could have some, pebbly components at the basal portions and some maybe more draped, faucet plane. So this is cross-bedded. And then the fascists 4, we can't particularly make out the crossbed or anything, but this is sandy from what we also know. Okay, so I am happy that you guys were able to identify, not just by saying 1 or 2, but the descriptions are the more encouraging comments. You're able to describe them, and that is very commendable. And I want to say well done, everyone. So if you see the lethal log, that's what it is for location 2, and you have repeated successions of finding upward systems. But one thing I like from this discussion was you were able to still bring in reservoir geology into this discussion, not just the outcrop, which is what we want. Beyond the outcrop, description. What's other thing? How else can you apply the knowledge here to your understanding the subsurface, the business? So for those of us who are doing more subsurface work, it is outcrop analogs like this that give you a picture of how things can vary. Because what you have in the field for those who drill wells is just a few inches thick diameter well that you're seeing as a core. But in reality, in 3D sense, you see how things are changing rapidly if you're facing the outcrop. Meanwhile, you have a 7-inch well that is drilled and you're using the core and you're trying to use that to make a prediction of a field that could be, a lot of, kilometers in terms of extent, both length and breadth. But here in the outcrop, you're seeing within a small distance, you see how things are changing variably. That is what I wanted as a message for this section. How quickly, how uniform, how homogeneous or heterogeneous are our reservoirs? What are the baffles? What are the barriers? How can surface analogs help us understand what is subsurface? So if you're building a model, for those of you who build models, this is also a wake-up call that things can change very quickly, and sometimes you really don't have a lot of information as we think we have when we build models. Okay, so that's just part of the additional message I wanted us to get from this section. Yeah, so it's 3 minutes before our break time. I think AEIC, this is about it for this section.
Okay, good. So before we go on break, it's important to know that your feedback to this session is very important. Okay, so the feedback committee or team have sent in a link to a form which I will drop on the chat board. So while you are having a quick break, I would like you to look at it and then please give in your feedback. Okay, don't keep quiet. That's the point. The whole entire essence of this is to create interaction. This is geology. This is a practical geology that we're all sought after, right? A lot of us graduated school without even knowing what's happening in the field, but technology has made it easier. And the team have taken the pain to go into the bush, diamond or consequence to make sure that this is put together. So please, you'll be doing yourself a disservice to keep quiet during this session. This will be like a turning point, the beginning of someone becoming a geomodeler, the beginning of someone becoming a proper geologist in the field and all that. All right? That's my encouragement to everyone on this call. Thanks to NAPE, thanks to DG Connect and the entire team to this. Thank you, Dr. Ifeanyi.
Thanks, AES. I don't know if we have location 3, Dr. Okon. There isn't much to do in location 3, right? Right, so that they can go on a break and let's decide when they reconvene so that we can fire off.
This
Any
break
thoughts?
is meant to last 15 minutes only.
Okay. So 11:45 maybe we'll kick it off from
It's
there.
11:30 now, so by 11:45 we can reconvene. Go get yourself a cup of tea or a bottle of water and then stretch your legs a bit and then come back. Thank you. So we're going to stop 4 right now, right? Mid-Albion Farmosine limestone.
Yeah.
For those of you that joined late, if you check the screen, you'll have an idea of the itinerary, okay? So just take a quick look. You could do a screenshot and keep it by the side so that you also follow. All right. Are you ready to share the stuff for? Stop sharing.
Okay, Dr. Kon, let us know when you need the video on. I have it ready to share.
Okay, so I would like us to start with the video. So maybe right now.
Okay. Let me know if the screen is up. Can anyone confirm?
Okay.
Is the screen up? I'm sharing my screen. Is it up? Anyone?
Yes.
Okay. All right. So this is location 4, the Infamosin limestone. If you look at the strat column, yeah, that's where we're at.
Hello, everyone. This is NAPE VFT 2025. I'm Dr. Emmanuel Okun. You're welcome to Infamosin limestone location. What you see around here are limestone pillars, of course, made up entirely of bioclastic limestones. They are virtually carbonates. This is the section of the Calabar embayment that has limestone development over the sandstones of their formation. So you see, this records the first marine incursion into southern Nigerian sedimentary basins. So it's shallow marine deposits of pure limestones, and directly overlying this limestone formation is the Ekempong Shale. So what you'll be seeing in the limestone will be shell fragment, predominantly stromatolites, algal remains, gastropods. So what will be missing, you may not see so much of barnacles. So if you are very conversant with these grain types, you will discover that barnacles, where do you find barnacles? Where do you find much of your oolites? And what we see here, so much of that. So it's left for you to decide what environment you want to call that. So I would like you to enjoy the trip through the Infamosin limestone and see how beautiful these structures that are remaining are. Do not forget also that there are areas where we have sinkholes, karst features, some of which we may not be able to access now because of vegetation. The Infamosin, again, is mid-Albian in age, and you see how we go from Neocoman, the Aptian formation right into the mid-Albian. As we progresses further, we'll see more of younger sediments. All right, enjoy your trip.
All right. Thank you very much, Doc, for that introduction. I will stop sharing, so you take it from there.
Yes, we're in BFT. We're doing BFT.
Yeah. Hey, Isaac, we can hear you. Okay. Dr. Okon, are you speaking? We can't hear you.
Okay, you can hear me now?
Yes.
Okay, here we are.
Volume up, yeah.
Thank you. So we will just follow the same drill to access the link for location. From your end, you can click and follow us as we go through it. So again, what we have here is one of the standing pillars of the relic of the limestone around this area. Again, we are dealing with carbonate rock now. We left a location where we had typically plastic rocks. Now we are in an area where we have sharp carbonate rock. Of course, there are several things to think about. What are the conditions for which you have carbonate rocks forming? These are the things you want to have around your mind to rediscover interpret the value and where this form. Do we have good light penetration? Do we have less of the plastic? Why was it so? Were there abundant fossils? What were the additional conditions during which this formed? But what we should have at the back of our mind is that we have from what is documented over 450 meters of
yeah, the voice is low. Hey, yes, the voice is low again. Sorry, Dr. Kun.
So can you hear me now?
Yeah, we can hear you, just not quite loud.
So we'll illustrate that now. Okay.
Okay. Do you want to confirm you hear clearly?
Yes, this is
Okay,
much
great.
better.
Okay, great. So what we have here on this photograph is a standing pillar of one of the relics of the Infamosin limestone. So you could consider that a long time ago, all the places around this place had limestone, but this is standing. So these are some of the things we'll be looking at while we go through. Okay, so yeah, this is.
I think your sound is gone, if anyone is speaking.
Yeah, can you hear me now?
Yes.
Okay, great. So this is an aerial view of the section, the stop 4. What we see around here are standing water. Then these are the limestone pillars around distributed in the area. So we go to stop 4B. And here what we have is the pit, mining pit of Lafarge Cement Company. So zoom into this. So this is a photograph showing the mining section. It can, So what you have here are different benches of mined limestone unit. So this gives you an impression of the thickness of this body in this area and how much have been excavated within this pit. So again, we can take a tour around the stop 4B where you have different units of. So this limestone again overlies the Awi formation we looked about before this section. So it is an introduction of shallow marine into the Calabar flank, what we would normally call the gateway through which marine incursion came into the southern Benue Trough. So we had shallow setting and then less of siliciclastic inputs, and then you were able to have good conditions like water clarity, oxygen, then the organism stripes, they are remained well preserved, and then we have the limestone buildup. So subsequently, there were changes in sea levels, drowning previously deposited, and more of them come. So we have a good thickness of the limestone within the Umfamosin limestone belt. Okay, so this is another aerial view, 4B3, taking us through the quarry pit. As you can see around where you have their infrastructure, and then the different sections where the limestone is being mined. Typically, we have good quality limestone in this particular area. So then this is another section showing the limestone pillars in plan view. So this is a three-dimensional view. And then all around it are what will normally approximate as their deep sinkholes, cavernous structures, and not too far away where they have been mined. And the reaction of dilute acid on it shows some effervescence. Yeah, the release of CO2. And this is typical of the Mfamosin limestone. Okay, so in summary, this particular unit tells us that we have already an entry of the marine into that particular section of the basin. Though not deep marine, shallow marine. That's why we have abundant carbonates. And then the kind of what make up the grain components of the limestone will tell us more about where it is found. Is it warm? Is it cold? Is it temperate? Is it tropical? So these are the things that will form the discussion when we are looking at the activities involved in this. So more of your oolites, gastropods, fossil remains, and then stromatolite, algal remains, dasyclads, and others are what we find within the limestone. Okay, so again, it is mild Albian in age. So we are younging from where we started from. So the traverse is from the Neocomian to Aptian, and where we are is the mid Albian Mfamosin limestone. Okay, so thank you, Dr. Ifeanyi.
Yes, thanks, Doc. How are we doing on time? Let me know how we steer this. We are supposed to get done with this by, this is top 4. So we do have some very good time, very good time. We were supposed to finish it by 12:25. I don't know if we want to, sort of fire on to the next location 5, and then we do an activity after that one. Or does anybody have any comments or questions on this location before we go to location 5 or stop 5?
So maybe we want to talk a little more on the limestone, right? So, okay, so no response from Ifeanyi.
Sorry, was there a question? I have a hand up. I think it's better to let's take reactions and discussions on this before we go to stop 5.
Okay.
Anyone, I'm trying to join a short meeting, but someone can help me anchor.
Hello, good morning. I saw in the area there's a lot of water, and I wanted to ask if, because of the chemical bonding that's in the limestone, does the water not affect the limestone? Where is the water? Does limestone normally occur in areas with water, or it's just the nature of the area?
Okay, thank you very much for your question. Okay, so those areas where you have are just subsurface, or like for this particular one that is being viewed now, is a mining pit where groundwater is almost overtaking the area being mined. So it's not as though limestone is averse to where water is found, or water is a challenge to the stability of the limestone. The rock has been formed. Okay, but sometimes where there is what we would normally call acid-rich water, they can cause dissolution within the limestone. So these are the reasons why in the subsurface, in some cases, we have underground caves and sinkholes. But on a long run, it's not as though the water around is what dissolves the limestone. Yes. So your observation is good. And then you discover that we could take you a traverse through the Mfamosin belt where you see different caves, which are relics and examples of underground cavernous bodies that have been exhumed. Okay. So this gives an indication again of the kind of reservoir properties of the limestone. Where you have solution structures as big as caves that is the size of a room or several rooms, it tells you what you want to see in the subsurface at different areas where, hydrocarbon can be charged in. So the model for reservoirs of limestone or carbonate rocks are a bit different for that of siliciclastic rocks. Okay, so James is raising his hand. James, can you?
Thank
Yeah, thank you. Yeah, I also want to add
And also,
with what Abdul Hamid asked. Most carbonate quarry are always flooded because some of the units of the carbonate are good reservoirs. And I've also observed this also at Ibisi Quarry at Ogun State, where Iwekoro limestone is being mined by Dangote. You will see a lot of water in the mines because those water are actually coming out from some of those bioclastic limestones that actually have good reservoir. So the water that is seeing currently are not necessarily the water that form the limestones, but some of the water that have been hosted in the rock that as a result of mining, some of those reservoirs are opened and the water will start flooding the mine site. Thank you. That's just what I want to say, contribute.
Okay, thank you very much. That's a very valid contribution you have given to us. Again, we would also view it from the point of the nature of the water table close to that area. So if it is intercepted during mining, then it's something the miners will have to deal with. All right, so thank you very much. You are correct. It's not the water that formed the limestone. It's limestone, it's water around the subsurface in those areas. Thank you very much.
Do we still have
Thank
any
you
hand
very
up?
much.
Yes, Doc, can you hear me?
Yes, go ahead.
Yeah, there is a comment on if more light could be shed on the sea rise in terms of this location.
Okay, so, okay, thank you for that question. That's on sea level rise.
So just give us a
So-
minute. We will come to that after Dr. Okon. We will also get to sea level rise discussions more
Okay,
after this location. But Doc, please go ahead.
Okay. Okay, so in order not to preempt that further discussion, I want us to look at this from the point of, when the Benue Trough was initiated, the rifting, the first sediments that we see were the ones that were just coming off from the hinterland into the depression, the accommodation space that was created. And then subsequently, there was subsidence that allowed for marine incursion. So it is up to us to look at, is sea level rising? Is it falling? What do we expect to happen there for us to see marine fishes overlying continental fishes? So I'll leave it there so that the activities and subsequent discussion in sequence will be able to shed light on that. So, Dr. Ifeanyi, are you around?
Yeah, give me another 5 minutes, please. Well, only maybe we can go ahead with the location 6 because we don't have an activity for this one. So it's after the next location, which is top 5, that we will have an activity. So when we get there, let me know. Maybe I can play the video first for stop 5. There are 2 videos, and then you drive it, after which we can now do the activity.
Okay, so will you play the video from your own end?
Yes.
Okay.
It's because what I have is not, it's the actual video itself, not what is uploaded. So it's going to be, I think, clearer. Yeah.
Okay, go ahead. When you're ready.
So stop 5 video, I'm going to play it now.
Okay.
So yeah, and then Sam, also share the link to stop 5 so that we're all on the same page.
All right, hi everyone.
So while we're doing that, waiting on that, quickly go into stop 5, or maybe what I should even very quickly do will be to point you to what the column says, what the strat column says. We are in the, just give me a second. We've just looked at Information limestone, right? That's stop 4. So we're now moving on to stop 5. So this is just me sharing. Give me 1 second. All right, so let me know if my screen is up, if you can see it. Anyone confirm?
Yeah.
Okay, so this is the stop 5 and the star. What you just listened to was the Information limestone, which was stop 4, generally shallow marine limestones. So we're now moving on to the Kempon formation, which is stop 5. If you also have the field guide downloaded, please take a look. So let me share the video for that. Look, there are 2 videos. Okay, I think I have the next video coming.
All right, hi everyone.
Okay, like
All right, hi everyone. Again, welcome to the NAPE VFT 2025. My name is Fine Chukwubi, and I do have with me Dr. Manuel Okon. We're working together, studying together. So we're here at a location studying the rocks here, and this formation behind us is the Ekempong Shale. But the quick thing we want to begin with is drive your mind to sequence stratigraphy, right? If you recall, we're in the Calabar, of course, the Calabar flank or Calabar embayment, whatever that is called. But we started off looking at the contact between the basement and the sedimentary. And if you recall, the first formation we encountered was the Awi formation, right? And those are generally continental deposits, largely fluvial because of the signatures of modal deposition. And of course, pebbly sands, and with everything we've seen there, definitely or largely fluvial. And then we progress to the next formation, which will be the Formosan limestones, right? So that tells you something. We're going from fluvial to a limestone environment. That means something is changing because limestones are deposited generally in the shallow water conditions, right? With all kinds of organisms because they are bioplastic, biological limestone rocks. So the environment is changing from continental / fluvial to the shallow marine conditions or shallow water conditions where we have the Formosan limestone. And then we now progress to the Nkempong formation, which is where we're at. What you are seeing here are largely mud rocks. If you want to go in a little more detail, these are shale beds, but you also do have interbeds of these resistant units. We call them, well, depending on whether you see effervescence or not, it could be siltstone, could be milestone. But the most important thing to focus on is that you have intervals of shale beds, separated by this resistant units. And in a sequence stratigraphic perspective, you want to think of what is the implication of this, right? Water condition is deepening, depositing the shale. Then you have some porosity, which leads to this phase is where you have this resistant units, subarachnoid exposure for some time, and then the sequence repeats itself. So think of parasequences and what this really could mean in the bigger picture. If we leave this location, we'll progress to the new native malformation, where we also see largely, of course, milestones with shale, of course. And as you think of this, as you go on this expedition with us, think about how things have evolved within a sequence stratigraphic framework, from the Awi formation to the Formosan limestone. Now we're at the Kempong shales. We're also going to see the new Netimal, and then eventually you have the Santonian activity, and then the Oro group, which is again another marine cycle. So just think about this whole expedition within that sequence stratigraphic framework, and hopefully you get some new insights out of this experience. So I'll leave it to the doc to take it from there. Yeah.
All right, I'm going to play the next one. Thank you. Just give me a second. Did that come out at all? Any confirmation?
Not yet.
With respect to the video?
Yes.
No, it's not up yet.
No, the one that just played.
Oh, perfect.
Fantastic.
Perfect.
Okay,
Yeah.
thank you.
That's it.
Thank you. Sorry, I like to get confirmation so that it's not a lecture, it's a discussion. All right, so I'm going to play the next one now. Coming right through.
That's a great one. So our minds are focused on the packages, segmentary packages that you see within this Ekengkong shale. So you also look at the fact that the Ekengkong shale, we know it to be Cenomanian to Turonian. So if you look at it from the larger picture, we have a continuity of this formation in some parts of the southern Benin Trough, but from there, you see it from the upper part, the Ezeaku. The Ezeaku formation is about latest Cenomanian Turonian. So we see. So you see that marine influence were earlier, much more here within this part of the basin, and then later progressed into the hinterland. So you see all these as we move along with the expedition. So the shale, like he rightly said, is younger than the limestone, which itself is younger than the sandstone. So we have been traversing from the start, from the Neocomian, and we are now in the Cenomanian Turonian. I don't know who is going to try to do this trick. As soon as we go, we are going to get to the more recent part as we go. So enjoy the ride.
Thank you. Thank you. And then we will talk more about how this whole thing relates to the evolution of the Benue Trough, where you have the triple failed rift, the whole Benue Trough thing opened up, northeast southwest trending, sub-regional falls, and then in this part we have northwest southeast trending falls, that's the Calabar, like as opposed to what we have in Benue Trough, and how that opened up and the sea, brought in this marine conditions and marine deposits. So sit back as we progress. We will talk more on this. Thank you.
All right, thank you. Thank you. I don't know if that came out fairly okay also. Apologies. It in your link, if you open the link, right, that location 5, right? Those videos there, the video icon there, you can play it individually. So it's already there for you. If you play it on your device, it's going to be much better than what you're hearing via Zoom, which is what I'm playing. Yeah, it may be difficult because it's challenging here because it's network and everything, but yeah, you will get better feel when you play it via your device. Okay, so I will yield now for Doc to take it from here.
Okay, thank you, Dr. Ifeanyi, for the ops for this location 5. So we'll again start from the aerial view to see where we are within the Calabar flank. So where we are at somewhere close to the what we'll normally say the geologically famous Odupani Junction. There is actually an evacuation route from the Lafarge cement plant up to Odupani. So this road cut gives us a good view of the Kempong Shale at about this point. So we would like you to see where we are in the map. So this is what I described, the Odupani Junction, down to where we have the Lafarge plant, somewhere down here. So this location in perspective is about this point. Okay, so we'll start with the step one. We have seen the video, and then what we have is okay, so these are typically, okay, so mile units above the shale. Stop.
Yes, he's unmuted. We can hear you.
Then what we have here. Okay, so these are the shales. Okay, so I want to speak to this particular picture. You see that we have characteristic dark gray, very fine grain, fissile, and then a unique resistance unit here that is rich in septarian nodules. The rest of it's well, resistant milestone in cases and silty milestone in other cases. So this acts as a different bed and it continues up. So in the general picture, this is what you see. So the thick shale, a thin layer of the mud rock, which is mostly marls. Then you see another thick shale. It continues like that, almost in cycles. So it's important for us to take note of that. And if we want to look at it from a rear view, you see the same thing. Our ability to observe the distinctions and where these are located is very key in description, because we'll be expected for every sedimentary unit to draw a little log. And that little log should contain the observations that we have made. Okay, so this continues in plan view. Again, we see the resistant mud rock and then the fissile shales again underneath like that. So these are typically what we have in the Ekempong shale unit. Of significance, like mentioned earlier in the video, Ekempong shale is Cenomanian to Turonian in age, and then it continues into the rest of southern Benue Trough as Ezeaku shales. So in that case, that's latest Cenomanian to Turonian in age. So it's a complete section is more seen within the Calabar flank when compared to elsewhere. All right, so this we go down to stop 4. Stop 4 has also a view of the shale. Zoom in, you'll see clearly. This is all what we can do from our end. So you see that underneath this shale, if you look carefully, you might observe some thalassinoides underneath this unit. So there are areas where you have trace fossils. And what do you expect in places where trace fossils are found? Maybe you have living conditions where organisms can, thrive. So these are some of the things we bear in mind while we go through the formation. Again, from this particular image, one thing that is key that we can see is that from this section, from the far right-hand side, you observe that there is a mudstone at the base, the shale. As you continue, as we begin to go towards the left-hand side of the screen, you see that beds that we have not seen on this side, we are seeing them on the left-hand side. So what that tells you is that you are younging as you are going towards the left. And the more beds you probably wouldn't have seen here, you see it much later in this area. So that's instructive when we are logging this particular unit on a general note. Okay. So let's go to the last video. So this is also a plan view that we could take that shows the Ekengpong shale. All right. Good. Okay, so we are going to entertain some activities after this, and it will generally be led by Dr. Ifeanyi.
Okay, maybe before we go into that one, thanks, Doc. Thank you very much. Does anyone have any quick comment, questions before we move on? How does it feel with how is it going on your end?
Are we tired?
Are we tired? Question. Okay, I see a hand
Good
up.
afternoon.
Let's
Question.
please go ahead. I'll just mute. Yeah.
Okay.
Dennis.
When he was talking, he talked about it being young in when he will move leftward. I don't really understand what he meant by that. I would be glad if you could maybe throw more light on that. Thank you very much, sir.
Okay. So still on this photograph on your screen. So we can observe that there is a mudstone unit that extends from the right-hand side towards the base of the left-hand side. So if you move directly upwards, you'll see another one on top, and then another shale unit. Okay, so as you continue that way, you'll see that there are little or, well, probably about 0.5 meters of shale unit here. But as you go further, it begins to become maybe 1.2 thereabout thickness. So what I'm saying is that you are stratigraphically at a higher horizon at this point than you are on this side, using the same principle that we are aware of, Walter's law of fasces, that what you see stacked down, if you go laterally, you begin to see it displayed across. That's what I was trying to emphasize when I mentioned that. I don't know if I made that a bit clearer for you. It's Dennis.
Mr. Dennis.
Sir, I'm cleared. Yes, sir.
So one thing we can also do, Dennis, if let me just do your question is about younging, right? What direction, right?
Sir, yes, sir.
Okay, let me just for a minute, let me just share a slide, a blank slide, basically. I like blank slides because it gives you room to do things, right? So a lot of times you hear me say I have a blank slide. It's also like trying to start on a clean slate so that you can sketch and do other things. So let me, for a second, just say, if we have a slide like this, okay, And then this is what generally field geologists do, right? You go to the field, you have some, just do it. Hopefully it's not so terrible. Sort of, something like this, right? And you have plants just doing their thing, right? These are the real owners of this location. Yeah, that's their domain. Don't go there. And then for some reason, you now have some other rocks doing all kinds of funny, funky things, right? Different behaviors, different angles. So this is, and then you may also have some other representation. Or something like this. So call this A, call this B, call this C. Apologies, the writing might be crappy, but just bear with me. D, and just in that order, right? And F. Now, what this means is that if we are looking at a normal system where the stratigraphy, the way you have it, maybe I should actually have flipped it the other way around. In terms of what I'm numbering, I should just, yeah, I should do that, right? But more importantly, let's assume that these rocks are just in an order in which they are layered. 1 here, 2 there, 3 there, just like that, okay? In that order. Typically what you do in the field is first establish where did I come from? The last location, what was it? Is it older or younger than this one? Right? And then you get to this outcrop. So we got to Mfamosin limestone, which was older. And then we're now at Nkempong, where you now see, let's say for 1 minute, you see beds that are dipping in this direction doing this. The question is, I'm going east or west. What am I going to see? Am I going to progressively younger units, or am I going to progressively older units? All right, so sorry. Okay, so typically, if this is normal graded, things are not inverted, things are normal bedding, the normal original sequence of layering. If you're going to the right, you're progressively going to older beds, because you can see that everything above layer 1, 2, 3, 4 in that order are younger. If you're moving to the left, you're going to progressively younger beds. So what that means is, as a geologist, you are standing right here, right? Looking at this outcrop. Maybe that's you. I'm not sure. That's you there. And then you deciding, okay, I want to see more of layer 7, 8, and 9. Should I go west or should I go east? Okay, so with a section like this, keeping in mind that this is normal, it's not inverted, there's no reversed structuration here. It tells you, because of the deep trend I've seen, if I go towards the west or left, I'll be seeing more of the younger beds. I'll be losing more of the older beds, which is 1, 2, 3, 4. If I go towards the right, I'll see more of the older beds and I'll lose more of the younger ones. And that's exactly what this section like this will help you. So when you, for those who are not familiar, the deep direction, understanding the deep direction of the beds, as well as how it relates to the overall regional stratigraphic and structural trend, will help you know where to find either older or younger rocks. Now, if we take that understanding to this other location where we were, it will give you a hint for, okay, if I go in this direction to the east, what am I going to be seeing? If I go to the west, what am I going to be seeing? Am I seeing younger beds or or older beds? And I'd like at least someone to attempt to respond to that. From what we're seeing now, let's assume this is normal. We don't have any structural inversion. These beds are in that same order, the way they are. They seem to be dipping in one direction to the left, right? If we move to the right, are we going to younger or older beds? Let's get some reaction. If we move to the right, are we getting to older or younger beds? If we move to the right,
Pascal.
unmute someone. Let's hear someone talk.
I'm moving to the older bed.
Okay, that's one. Okay, any other thoughts? Let me see the charts. Older, 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 older. Great. So I guess we're all are mostly on the same page here. Okay, so now that that is off the way, that takes us to this exercise. This has been sent earlier on. I don't know. I hope that someone has attempted to do a first pass. You've seen the dark shields, the light dark gray shields. You've also seen the resistant beds, which have been called MAL, right? Take a closer look and carefully identify some MAL beds. See if you can get up to 3 or 4. And then based on that, imagine the thicknesses of each parasequence from the shale below and the capped by the MAL above it, and then see from the bottom to the top, how does it all fit? Are they getting thicker or thinner upwards as you look at each individual pair of shale and MAL together as one? What that means is, if I'm just going to explain, I have a unit of MAL like this. I have shale below it, right? And then I have another unit of MAL, and then I have shale below it again. So look at this thickness of shale MAL pair, right? Or MAL shale pair versus the one below, right? And tell me, as we go from bottom to top, is that thickness getting bigger or smaller? In other words, within a parasequence, if I call each of them a parasequence, right? The bed, the shale bed capped by a milestone bed, and then another shale layer capped by a milestone bed. Are things getting thinner or thicker? And then we can now ask in question C, which is, if the whole of this section is interpreted as marine, as Dr. Okon and all the very intelligent people of the past and present have said, if we call this section marine, which is very, very instructive, okay? Use your understanding of the thickness trends you've seen to predict whether the next location you will go, which I have told you is younger than this location, is above this. With that location, what will it be? What environment? Will it be more marine or less marine? So those are the 3 questions. Identify MAL beds, annotate if you can. Let us know if you're willing to share. Look at the individual parasequences. I did try to sort of sketch that. Let's say between here and here is 1, and then between here and here is another 1. In other words, on the section, between this MAL and this will be 1, and between the MAL below and the shale below it is another 1. How are things going? And then tell us whether, if this section is marine and I'm going to a younger formation, which is right above this, will it be more marine or less marine? So that's it. I hope the question was clear.
Yeah, it was.
Okay, please, if you have done this, indicate if you are willing to share, and then the admins, our panelists will unmute you, and you can give you right to share. And then we can also take chats also, and then we can go ahead and discuss. Thank you. I'll just leave it for some time so that we all digest it and soak it in. But if you're ready to share, if you've looked at it, if you've done it before, then let us know. If you're doing it now, you need more time, let us know. We are not in a hurry.
Oh, Lesson Lauren.
Blessing, you want to talk? Go ahead. I can't see your head. This class is too quiet. Is it time for a stretch break?
So first thing, we don't mind doing a 5-minute break and we'll come back.
Yes.
But this is not, we don't do this in a hurry. We want to digest it. Yeah, but if you're ready to share your thoughts or even ask a question, a clarifying question, you're most welcome.
So we have a response in the chat though.
Okay.
Mm.
Yeah, let them keep coming in. We'll have a discussion on them. But if your hand is up, maybe I think someone's hand is up. Go ahead.
Yeah. Sophie.
If you are going to the left, the thickness is higher, and also it's going to be more marine if you are going to the left. But if you are going to the right, the thickness will be thin, and it's less marine.
Yeah, so what I want you to check will be, first of all, draw the lines draw the very long lines for all the individual beds and tell yourself, what can you see? What is the last mile bed you can see? Do you think there is another mile bed that is deeper that you couldn't see? And then based on that understanding, the other mile beds that you've seen overall, and then look at it all the way to the left, highlight every mile bed that you have seen and tell us, okay, are things generally getting thicker upwards or getting thinner upwards? And then we'll now talk about if it's getting thinner upwards or thicker upwards. And based on what you know mile are, let me give you a bit of hints. Miles are actually indicative of periods when you have reduced rate of sea level rise. So if I have a shield that is largely marine and I have a milestone or mile above it, it's indicating that, okay, that was a period where the sea level wasn't rising so fast and it gave room for more siliciclastic materials, clay materials, to come in and then settle in. And then after that break, it's like a period of a break, basically, where the sea level wasn't rising so fast, or why actually sea level, either it wasn't rising so fast, or it stopped rising, or it was actually regressing, basically. And then another cycle of the rise. So if you look at all those trends, and are the miles becoming more frequent in this location? Are they becoming less frequent? And then either way, what does it tell you about what to expect in a formation that is above this? Do we expect more mile or more shale based on the thickness trend you see here? So you can just do your sketch first and then just open up your mind and think, okay? And think of what could be the trend. So I see an answer B. I see an answer 4 mile beds. I see another one ticking upwards. Okay, I'll give another 1 or 2 minutes. And then if no one is willing to or available to share their own, if you have a capture, we will give you room to share it because we sent this in earlier. You can snap it and try and do a rough one on a PowerPoint. You might just be the star of the day who is able to share, right? Be a co-instructor. So let's know if you're willing to share anything. Other than that, we'll limit it to the chat in the box if you're unable to. So we'll still give a couple more minutes before we get back.
So keep coming. Allow the comment to speak. Well done, please.
All right, so let's take reactions. Are we here? Just to check again, can you just indicate your presence by just doing something? Raise up your hand or do something, walk around, talk to your neighbor. Let's know that you're there. Raise up your hand. Let's be sure the people are not sleeping, because this is it's lunchtime. Some people may have had lunch, and I know you took tea. Who knows? It's probably making some people tired. Yes, I see hands, and okay, we are all awake. Okay, you know, one way to also test being awake is to say something that is very wrong and hope that nobody will say anything, and then people will start saying, no, it's not true. And great, I like the reaction, thumbs up, hands up, reactions here and there. So well done, well done. I think we're there, we're there. So let's now look at responses. 3-mile bets. If you want to verbalize your response and you want to, because this is Zoom, if you want to annotate on the screen, indicate, raise up your hand, and we will give you that permission, Mr. Lawrence, please, so that each person can sketch if they want to on this screen while it's projected. For those who say 3-mile bets, 3 to 4-mile bets, give it a shot. Do you want to sketch? Do you want to say something? Even if you don't want to sketch. Before we go into the reaction response, the class response. Is anybody ready to do that? I think there are 2 hands up. AEIC.
Yeah.
Those more hands are coming. Let's allow them, empower them to be able to sketch on the screen before we go into the class solution. Or at least try to sketch and see if it doesn't work, then we will do something. Or we can move the person to...
Yes,
try.
please, if you're muted, you can speak.
Yeah, hello?
Yes.
I don't want to sketch, I just want to maybe explain.
Okay, fire on.
Yeah. So the mal bets, I think we have four different layers, 4 different bets from each. The colors are very similar, but from what I can say there's maybe 4 different mal bets. Then also for the thickness, I think the individual mal are bearing parasequence, and they are kind of thin, leaning to upwards, and they are overlain by successive light mals layers. And they could be associated with coarse or shallow parts parasequence before the thinner and less developed obstruction. The obstruction is a bit thinner than the one lower. Then for the location, I would say it is thin upward in a parasequence tent, which indicate that the sea level will rise. Yes, and overall which indicates an overall sea level rise. And also therefore there might be a deepening upwards. And from the nature of deposition, there might be younger rocks which are likely to be deposited. And yeah, I think that's it. Hello?
Yeah. Next
I'm
person,
done.
please, shoot. Dennis, go ahead.
Okay. Good afternoon. Good afternoon, everyone. Good afternoon, everyone. Okay. So for the first question, so currently identify and annotate 3 to 4 malbeds. So now for the malbeds, I would say they are the one that show a different color that's in this structure we are having here.
Can you
And
annotate?
I
Is it
can
possible you
identify
annotate?
4 of them. Hello.
Yeah, can you
Okay, I
annotate,
can
or is it
identify.
possible you try to annotate?
Okay, I'll be very fast. So I can identify 4 of them. So the first one, I would say that it is just above the road.
No,
That's
I was
before we
saying
talk.
that. Sorry. Is it possible you try to annotate? Let's test it if it works. Can you try to annotate, or you're using a mobile phone? Can you use the annotate tool, or if you can't use it, that's fine.
Yeah, I will just prefer to say it this way.
Okay, no problem.
Yeah.
Go ahead. Thank you.
Okay. So the first mile is just above the road. I would have loved to do it just like you said, using the PowerPoint, but I was not able to do that. So just above the road, we have one, and then just like I said initially, the one with the different color, that's what we refer to as with my own observation as the marbed. And the second one also, that's when we have the shell bed. Just above the shell bed, we have the second marbed. Then also we have another sequence of shell bed. So we have the third one, that's the third marbed. Then above the top marbed, we have another shell. Then at the very top level, we have a marbed. Now, concerning question 2, if it is thickening upwards, or it is thickening, or if it's thinning, from the observation we have, or what I'm seeing here, I would say that it is thinning upwards. Yes. And it will get to a position where we may not see these mar beds again. They will not be visible, and we'll have more of shale beds. So sir, these are my observation. I can't really attempt question 3, so I will just stop here. Thank you very much.
Thank you very much. Great response also. Well done. Anyone else? Yeah. Pascal. Can you unmute Pascal, please?
Pastor. Pascal. Where is he?
Hello, good afternoon. Can you hear me?
Yes, we
we
can
can
hear
hear
you,
you.
Pascal.
You can try to sketch if possible. I'd like someone to test it. Let's see if it works. If you're able to sketch on the screen using the annotate button, but if not, just go ahead.
I can't find an annotate button on my screen. I don't have any button to annotate.
No problem. Just go ahead. No problem. Go ahead.
Okay, so the first malbed is the one just above the road. It's just the one above the road, after which there's the shale bed, and then there's the next one, the lightly colored beds, which are also kind of it looks like the shale beds are eroded, but the mal beds are not as eroded as the shale beds. They're like standing out a bit more than the shale beds. You can see them. And then above that, there's one which is not very distinctive like the rest of them. That's the third mal bed. And above that, just above where the image is about to end, close to the vegetation at the top, that's where you find the fourth mal bed. So with these indications, to answer B, I would say that the individual parasequences, they are thinning upwards, which is a deepening upwards sequence, a deepening upward sequence. I think I can answer A and B, but I'm not sure of question C.
Okay. Yeah. So Sam, I see your message. Go ahead and put it on so that people can I mean, it's not a one-way thing. So enable it so people can sketch on the screen, right? If you can help with that. Because people are unable to see the sketch annotate button, and I don't want it to. This is not a sermon. It's a field work. We should be able to sketch on screen, and that's what I'm hoping to get. So yeah, if you do that, let's see who else. Or is Tunde on the call here?
Doc, can you
I
hear
think
me?
it's only Tunde that can do that.
Okay.
What did you
Okay.
want to do?
Fejiro, we can hear you.
Thank you. Yeah, I think for us to give us that permission, we have to promote them. That would be the easiest way to get that done.
Yeah, then promote the person now. Let's all bring the people, because those who are talking, I think by this time they deserve some accolades. We can bring them into the panelists so they can sketch. At least if you're promoted, that means your level is you're in the next level.
Okay, sir. So once I see a hand raised up,
Anybody
I'll
that
just
wants to
automatically
share,
promote.
raise up your hand. If you want to sketch something, you'll be promoted effective immediately, so you can share, and then you're now on top of the world like us too, you know. Okay. All right, Pascal wants to share maybe. So bring him in. Let someone sketch on this screen. Let's mess it up a little bit. That's the whole idea.
I've sent him a request. So Pascal, you can go ahead.
The section looks too clean for my comfort.
Hello, Pascal, can you hear me?
Yes, I can hear you. I can hear
Okay,
you.
so you can go ahead, please.
Okay. Okay, can you see the annotation? With I labeled 1, 2, 3, and 4.
Not
Hello?
yet. Not yet. I can see it. Can you guys see it?
We can see it.
Oh, really? How come I can't see it?
Yes. Dr. Ifeanyi, just click on his own screen from the top.
Okay. How do I see his screen?
Okay, you will see three screens,
Beside
webinar,
yours.
Dr. Ifeanyi, and Pascal. So you click on Pascal.
Okay, show webinar. Oh, okay. Okay, at least I learned something new today. Glad. Thank you. Is it still showing by any chance?
Yes,
Yes, it's up.
Okay, because it's like it's showing that Pascal is sharing, but it's not showing me. It's showing me a blank screen, so I don't know.
Okay, maybe it will take time from your own end, but mine is showing very clear.
Okay, oh, that's interesting. This thing is wayo, but there's something wrong. Okay, so
we learn every day.
oh boy, I agree with you completely.
Okay,
Yeah,
I
interesting
think
thing is that
for it to be easier,
I
Pascal,
will stop.
do you mind stop sharing, then you reshare again for proper reporting?
All right.
Yeah, Pascal, if you have your own document open, you can sketch on it and share your own screen. Except you don't have your document open and you want to sketch on the one I'm sharing, that's different.
Can you see it now?
Okay, I can see yours. Great. It's better now.
Yes.
Okay, I can see it. Okay, I think mine was even a Zoom that is acting up, not because of my network or so. Okay. All right, so I think is there any other thoughts coming? Am I still on this meeting?
Yes, I can hear you.
Okay. All right. Okay, so thanks for sharing that. Do we have any other person who wants to sketch? I've seen your numbering and yours, very well observed. Any other idea before we do it together? Okay, so I think let's just move on. Well done, everyone. I want someone to guide me as I'm annotating on the screen, as I'm sketching it, right? So I'll be sketching and then I'll need some guidance from you, okay? So let me know if any of my sketches in order as it comes. So I'm going to sketch one. It may not look perfect. It will look probably crooked. So please be nice and don't laugh at me.
It's allowed.
So I've sketched one. Let me know if you've seen it. Okay, I did another one, even though it looks wobbly at the end. Okay, there's a third one. There's a fourth one. So there are 4 lines. Can anyone see it?
Yeah.
Okay. And then potentially there might be one below, which I cannot see. There might be one at the bottom, somewhere here, which we cannot see below. And the one above, but I think has been eroded by some, it's sort of eroded by.
The bushes were not there.
Yeah, bushes is covering things. So I'm going to just say this is what this looks like, something like this. Okay, so generally, if you keep in mind that there could be one, let's number this. Let's just say we have, I'm going to use a cyan color. We have 1, 2, 3, 4, and maybe a 5th one that is eroded. And let's assume there's a 0. Do you think that there could be a mal layer below that we can't see?
Possible. Very possible.
Possible, right?
Mhm.
And if we assume that mal, because what we do again is work with what we have, and then if we assume that by some chance I use a dashed line, and I think there is a mal layer that this set of, geofellows couldn't see, and it is just below, right below it, just underneath. We just couldn't see it because it's buried. Now let's go with that mindset, right? Would you say that things are getting, on the average, thicker upwards or thinner upwards? Each layer of sand, shale, couple, as you consider it from 1, 2, 3, 4, do you think it's getting thicker upwards or thinner upwards? Type in your response. Type it in, type it in, type it in. Let them come. Let them come in. Let them come in. And this is how it works. Sometimes if you look at one location, you will make one observation and you would make a note. But in reality, if you step back and go left, go right, imagine what you haven't seen, look at the ones you have seen, look at the one that's eroded. I think there is one direction that this is going. It is getting thinner upwards. Yes. Okay. So thanks for the reactions, right? Thanks for the reactions. Now, that means, first of all, I think for those who responded that you have 3 to 4 mal beds, you are very much on track. Okay, very much on track. So largely, we have at least 4 mal beds that we can see, or let's call it 3 to 4. There could be more, we haven't seen them. Okay, so that's correct. The second one is looking at the thickness. I think we've all answered the question. The individual packages of shale, mal, parasequences, that pair of shale and mal is getting thinner upwards. Okay. Now, the next question will be, if we all agree that shale here, each time there is shale, is marine condition. Each time there is mal, it is lesser marine condition, or rather sea level not rising so much, or sea level actually falling. Now, you have seen that the shale thicknesses are reducing upwards. Does it tell us that we're in the next location, which is above this outcrop, which we will see? Do we expect to see more mal? In other words, do we expect to see more shallower conditions? Or do we expect to see suddenly thicker shale? In other words, more marine conditions or deeper marine conditions? Type in your response and let's have a discussion. Type in your response. type in your response. I love the reactions coming in from this chat room. Okay. I love the reactions. The thickness here we're seeing, shale is telling us marine conditions, classic. The Atlantic opened, it brought in marine conditions. We're all happy, we know what it is. But then we also observe something, that each time there is a shale bed, it's capped, of course, by a marl, which tells us the sea level reduced its rate of rising, or the sea level actually fell. But then we're also seeing something from bottom to top, the thickness of the individual parasequences are getting smaller, meaning the shale is reducing in thickness and the marl is getting more frequent. It tells us that, okay, as a predictor, which we as subsurface and surface geologists, the next location which will be right above this, which is younger, will it be suddenly larger shale or more marl from what we're seeing? If this location and that location are close to each other and there is no significant unconformity separating them. Okay, I see more marl, less marine, because marl here is telling us less marine or less sea rise. And I think with these few points of yours, not mine, we do have an answer, a class answer, because majority here are carrying the vote. I'm going to go to the class solution and you will tell me how you performed. Okay? I am going to move, and in 3, let me slow down a little bit. Before I project the answer, think about your response one more time and imagine whether you're right or wrong. It's not a matter of what I say, it's a matter of what the science is, right? Which you've all seen. Okay, so I'm going to go back to projecting it. And I have projected. Let me know if you can see the slide. Okay, so this is the class answer. And I think you deserve an applause if you are in this line, if you thought about this. For those who said thinning upwards, for those who said I've seen 3 or 4 miles, please find a way to celebrate yourself in the chat room, because I didn't. And then the last answer, the last point that says in the next location, we will see the answer when we get there. The next outcrop, Dr. Okon here and Dr. Romeo will tell us whether it is more marl or more shale when we get there, and you will see for yourself also. But clearly, the first 2 observations was that we've seen the marl beds, and then we've also all observed that it's turning upwards, and I'm completely happy with that. And then the next one, we've also gotten a hint that the answer is shallow marine, because we have seen that we're getting more marl. We've seen that marls indicate shallower marine conditions than the shales here. We've also seen that marls tells us that the sea level wasn't rising so fast, or rather the sea level started falling and there was a period of a break leading to deposition of plastic materials, muddy materials, and those are the marl beds, right? So we will go there and see if our prediction is correct. We have said it's going to be shallower marine and it's going to be more marl, right, as a class. When we go to the next location, we will see that if that is by any chance close to being correct, or if we were completely wrong. Okay, so this is where I'll stop it from here. We will now progress. AEICA, what is next? Are we taking a break, or are we going to the next location?
We're actually supposed to take a break.
Okay, so it works for everybody.
This is a major break that we're taking today.
Major break. Okay, so when we come back, we'll be more energized to take on it. But by the way, everyone, well done. Great participation. I am interested in your observation skills. I know we have a lot of professors in here, industry folks who know these things very well, who live it on a daily basis. But my joy is not because of the industry folks or the professors, but the upcoming who are here and are sharing their thoughts, falling and getting up. And that's really that's the beauty of this, because you are the future of the industry. You are the hope of our energy for tomorrow. So well done, everyone. Thanks for sharing your thoughts. I'll leave it here. When we come back, we'll take it from there.
So we have an hour break. This will enable people that need to pray to pray.
Yeah, you can project the
then for
timings
us
too, so they know when to
Okay
come back.
then. If you notice on our agenda, the last leg of this is more interesting than even the the ones we've done already. You see, there are 2 more activities after break that we're doing. And you don't want to miss this. That's like the icing on all that we've been doing since morning. Dr. Ifeanyi and Dr. Okon and Dr. Romeo are saving the best for the last. So I'm just giving you an insight to what is happening here. And please don't forget to feed in the feedback forms at your convenience. I've dropped a link and I'll reshare it again. All right, have a good break.
So when are we coming back?
Now time. So it's 1:10. We're coming back at 2:10 exactly.
Okay. Let me even share the other slide. Okay. 1 second, 1 second. Okay. Okay, let me reshare the right slide, but it's about the same thing though, so just so you know. So this is the current slide we're in. If you remember, we were somewhere, we were doing an exercise, right? And that was the last efforts, the last thing we did before we took a break. So the idea here is, how do you connect your observation, and then how does your observation helps you make prediction? Okay, let me reshare the slide. Let me reshare the page. How does it help you make prediction? We all did an exercise where we made some, some observation as a team. And then from there, we moved on to, let me close this page. I think this is just completely wrong. Not sure why it's not showing me the right thing. Just give me a second. I have the wrong slide showing. Okay. Okay, so I'm resharing my slide. Let me know if you can see it. All pumped up for action. Just type in something in the chat room. Indicate that you're fully present in body and soul and mind, and you are ready to get on with us on this trip. Yes, make some noise, show yourself. Thank you, thank you, thank you. All right, great. I like the spirit. Okay, so this is it. We were previously in. Yes, well done. Thanks for being present, everyone. Thank you very much. We were previously in at the Ekemp Shield. We all went there together, virtually. What a miracle. And we all made observations together. Let me, for a minute, take us back to what we all did. We all made this observation where we went as a team to this location, and we were able to identify the marls and the shales, and we made some observation regarding the thicknesses trend upwards. It was reducing upwards, and most people, if not everyone, agreed that we had more miles coming in, and the thickness was reducing. Thickness of the shale beds were reducing, meaning we are likely to have more higher mile frequency, which means that because the mile tells us a lot about reducing rate of sea level rise, meaning we're getting to more shallower conditions. Hence, as a team, you all predicted that the next outcrop will be more of mile, and it's largely going to be still marine, but slightly shallower marine because we have more mile. And I think you all made the right prediction. When you looked at the class answer, your prediction of the thickness, your observation of the thicknesses reducing with time was right. and you also made your prediction. So now we're now in the next outcrop, right? Which is in the incidentally new NAPE formation. Dr. Romeo and Okon will drive through the real discussion. But just so you know, you were correct in your prediction. This new location has dark gray massive marls intercalating with flaggy calcareous gray shale, meaning the marls are now the commanders. They are now the ones in charge. In our previous location, the shales were in charge. The marls were struggling to show themselves, to be present. But in this other location, we had the marl so much that they call it the new NAPE marl formation. It's largely marl with shale coming in. And then when we get there, you will see more. So I'm going to play a video that quickly introduces that location. And then we'll switch over to the actual virtual expedition. So let me stop sharing this and then share the video that introduces that. Confirm if you can see a gentleman standing confidently with some bright smiles. Let me know if you can see his face.
With a bowler hat.
Correct, correct. So I'm going to press play and we'll all listen.
Welcome once again. This is NAPE Virtual Field Trip 2025. Right about now, we are on the new NAPE Milestone Hill here in the Calabar flank. So this mile is dated Conation in age. And one interesting thing about it is the intercalation of milestone and shale. Now, these units are calcareous. What that means is that when you drop dilute acid on them, they show effervescence. That characteristic also is exhibited by the shale. It's interesting that the milestone you see here is highly calcareous. The shales within it are also calcareous, as opposed to the shale underlying it, which is the Kempong shale, which we would have discussed, which is not calcareous. So it's easy to map across this unit based on their lime content. So what you are seeing here is an excellent intercalation of milestone and shale that becomes nodular towards the base and tabular as you go, as you young upwards. So these are some of the things you would be observing, and I'll leave it to you to begin to understand what happened in what allowed for the sequencing of this sediment, which is an interesting thing, something you want to pick out when you study this as we go on. So have a nice time of that as you join us on the trip. Thank you. Welcome once again. This is NAPE Virtual Field Trip.
So thank you, everyone, and thank you, Doc, for that video. I think by now we know the results of our efforts. We said we're going to find out the answer in the next location. So by now, you already know your performance. It's self-scoring, right? You all predicted that the next environment the next outcrop, which is younger, will have more mile, and that it means potentially shallower. You have your scoring there. And I think the class got a resounding A+, if you ask me. And congratulations, all of you. I will yield for Dr. Okon and Romeo to take it from here. It doesn't hurt to give yourself a round of an E applause, because this class did great. This class did great. Some applause will be very much in order. And you did it. I didn't do it.
Okay, thank you, everyone. I welcome back from that hiatus, which was very, very important. We appreciate every participant for involvement. So we appreciate every participant for your involvement so far. Your participation has been very, very top-notch. Sincerely, we say congratulations. And for those that did very well in the last exercise, we still congratulate you for your good performance. It shows the section is interactive and a rewarding one. All right, so as a follow-up, we have been taken through the sedimentary sequence in Calabar flank. We say from our formation, where we have the fluoro-detect position, continental deposit, and of course, the transverse down to the shallow marine of Pharmacine limestone down to deep marine of Ekenponshire. And within the last location, we had some exercise which we were asked to predict the next location. And of course, positive enough, we predicted rightly. Hence, we are in the next location, and this is known as New Netamar. Fine. This is area view of New Netamar location, as you can see. But before looking at that, let's look at the location map of where we are. This is the location of New Netamar. We can see it not too far from where we had our previous location, the Ekenponshire. This is the location of New Netamar, and is dominantly consisting of marl deposit in this location. All right, so this, like we said, is a representation of area view of New Netamar with ridges of marl deposit across the location. All right, so let's go to step 1. Fine. The location of New Netamar is dominantly made of marl, but with interesting intercalation, consistent sequence of scale marl intercalation in this formation. And what does that represent? We have followed up from our formation down to Pharmacine limestone, the Ekenponshire, and down. So it's understood that we have followed the sea level rise and fall within the Calabar flank. So what that implies is that the role of sea level fall and rise has played significant role in the sedimentation package in Calabar flank. Hence, if we are looking at a typical section of New Netamar, we can see frequent occurrence of marl deposit interbedded with shale. Shale deposits are interbedded with the marl section. So the implication of this is we have moved from a deep marine setting to a shallow marine setting, right? But in between, you have a concurrent occurrence of both deep marine and shallow marine setting within, depositing the shales in between those locations. But you can also look at it. Close observation will also show that. Let's take a close observation of this, and you see closer look at this shows that the shale sequence are ticking upward, right? So we can also interpret or we can predict what we expect to see in the next formation from this. These are interbed of marl and shale.
Yeah, the sound, Doc, the sound is sounding far from the microphone. I think it's maybe you were closer to the microphone before, but not now.
Can you hear me now?
Yeah, it's still sounding like you are in the other location. Not close to the microphone, yeah.
Is it better?
Okay, come close. Yeah, keep
Can you
coming
hear
close.
me?
We're doing better. Yeah, it's better now.
Okay, that's fine. So, all right. So this location represents New Netamar, where we have a frequent occurrence of marl and shale intercalation. And what this represents is there is a shallow marine or drop in sea level sequence, right, which deposited the marl, and this subsequently resulted to rise in sea level. The shale were deposited, but dominantly, this is consisting dominantly of marl. And the marl section here, if you a closer look of this section shows that the shales are thickening towards the upper section of this. And what that implies is that, okay, there is a rise in sea level. Okay, let's take a closer look at this. And that can be predictive enough. So we can see a closer look. This is marl. We have shale interbedded within the marl section. As we go upper, the shale thickens upward. From the last location we had, we're able to predict that, okay, we had a marl section. Now looking at this, the sea level increases, which have led to deposition of the shale. So predictively, we can say, or we can predict the next formation which will be deposited on the marl section. So, however, most of these marl deposits are bioturbated. They are rich in ammonites. Let's go to stop 2. We could see a continuous section of marl shale sequence in this location, which indicates the role of sea level rise and fall in Calabar flank with the deposition of shale and marl intercalation. This is a typical ammonite section observed in the New Native marl, depicting a depth, shallow marine environment. Okay. All right, so we will take it off from here, allow the students to predict what the next formation will be, having seen intercalation of marl and shale in this sequence. The shale are thickening upward, so we can predict what we expect in the next location. Is it going to be deeper marine or shallow marine? So we leave that for the student to predict. Thank you.
Yeah, thanks, Doc. Thanks, Doc. I don't know if Dr. Okon, you want to chime in something before we go into the activities.
Yeah, so thank you, Dr. John. So what we have here is for conation in age. So we've seen ourselves gone from Neocomian, Aptian, and then we've seen Mid-Albian and Famosing. We've seen Cenomanian, Turonian, Ekengpong Shale. Now we are in the Coniacian New Net information. Again, we have seen the multiplicity of milestones and interbedded shales. So again, we've been able to show that, or well, draw attention to the fact that there's some characteristically different feature that the shales, display here than they are in the underlying Ekengpong shale. While these are calcareous, the one underneath are less calcareous. Now, this is being said because one day or the other, someone might want to map this place physically. So you want to see that these are some of the features that you use to distinguish these geological materials. Again, the milestones are characteristic of their shallow water conditions, just like the shale relatively deeper. So if we have an alternation of marl shale in this frequency we have, could it be that there was an unstable eustatic curve there or local variation? These are things that we want to think about. Okay, so as we look through the exercises, we may be able to provide solutions for this. Dr. Ifeanyi.
Okay, right, great, thanks. Yeah, so let's get on it. See what today's Let us get on it real time. Okay, so I'm going to share a slide that will probably sort of drive this exercise or this activity. By the way, this was also shared earlier on, I mean the activity itself. So if you had been able to just take a look at it, yeah, we'll be appreciated if you don't mind sharing your observation. So we're on a new netting mile. So if you look at this next slide, it's a close-up rather. It's a close-up. Because of the way this is, the slope of this place, it's like a step. What you are seeing in terms of the shales will be apparent thickness, not the, sometimes it looks not so clear in terms of the thickness of the shale. But again, what might help will be look at the logs to your right. People have worked this in detail. What is very clear is that the milestones, which you see here, are very competent and better defined at the bottom parts. And then as you go upper, it's either it maintains the same thickness or it looks like it's reducing. This is one section of it. If you already have the, what is it called, the virtual package, so you can move around and play around also to see other captures. I just took a picture of this, one of the pictures. And you also see those shales, which even in the virtual package, you may not really see very clearly, but in this picture, you now see those shales. Why the shale might even be more challenging to see sometimes is maybe part of it is eroded, but the marks are very competent. That one you can see that, okay, this is what it's showing. So if you make an observation on the log and on the section, let us for a moment all agree that the mouths are reducing in thickness and we are getting more shales. Okay, why did I say that? From the beginning, from the bottom, you see that we have very small amount of shale here in this where my cursor is. You have a marl bed, and then you have another shale, which this is not the vertical thickness, but it just spread out. And then you have another marl, and then you have another shale, and then you as you go up upper sections, you're beginning to see more shales. Here we're not getting the proper view of it. Okay, and then we have a bunch of marls also. So the cycle of shales are not like all, in this section all showing. But what we see is that from the bottom where we didn't see shales at all, or where we didn't see enough shale, we're beginning to see the shales come out more competently. And away from this particular capture, for those who have worked this formation better, the thickness of the shale is increasing as you go shallower. Now, the number one question is, let us assume you know what milestone represents, right? Reduced rise in sea level, exposure leading to exposure of the let's say the bed, the seabed or the shelf surface, where you now have more detrital materials coming, more clay or gritty materials coming. So that's telling us there's some form of regression or some form of reduced transgression, right? So if you look at the mal and you now notice that the thickness of that unit that indicates reduced transgression, if that thickness is reducing or about the same or reducing upwards, what does it imply? Especially now that you also know that shales are beginning to come in more prominently, Now the question will now be, will you say the sea level was rising or falling? I like some reactions in the chat room. And then if you think the sea level is rising or falling, based on what you know, shale indicating sea level rise, mal indicating reduced rate of sea level rise or actual sea level fall, and the mals are reducing in their thickness upwards from the log drawn, not just from this section, but from other locations worked. Will you say the sea level was rising? And then with that in mind, would you expect to see another mass of mal in the next outcrop, which will be shallower than this, the next formation, or would you expect to see more shale in the next formation? So that's the question. So let's get some inputs, some reactions, and then we'll get you to talk about this. Let's get some reactions. Shale here indicates they are both marine, by the way, but one is deeper marine or just marine. The other one is shallower conditions within the marine setting, right? So if you have the thickness of the marl, which indicates reducing rates of sea level rise and or actual regression, and you have that thickness reducing vertically, very clearly, at least in this section, and then you now have shales from not a lot of shales to now having shales beginning to show up, then would you say the sea level was rising or falling in this vertical sense? And then secondly, in a predictive sense, would you expect to see a bunch of shale or marl in the next location or the next formation, which is right above this one, if we do not have serious unconformity? So I getting reactions. If anybody wants to talk, you can indicate on mute. We'll take a couple of feedbacks and let's hear you. Okay, I think it's almost clear, right? Almost everyone is saying sea level rising, which means I think you get the gist, basically, you get the gist. Shale indicates something. Marl is telling you the sea level is not rising so fast, so you already get the gist. And the two shales coming in, more shales coming in, telling you, okay, we're deepening upwards. All right, that means we should look for a mass of shales somewhere in a nearby location, in a shallower formation. So yeah, hands raised. Please go ahead if you raised your hand.
Okay.
Let someone unmute them. Let's hear. Prof is here. Professor Deke is here. And Fupre.
Oh, nice. Welcome, Prof.
Okay. Okay.
Yes,
Good day,
go ahead.
everyone.
Good day.
Okay, so from the lithology, it was initially marlstone. The thickness was more, indicating shallow marine. So as we go upwards, shale thickness became more, so indicating that we are going deeper. So for the number A question is the sea level was rising. So for the B question, I will expect to see more of shale since the sea level is rising from the A part.
Okay, so you're telling me that I should expect more of a source rock material. Let's not start thinking of the petroleum system elements now. So if within a petroleum system framework, we are saying there should be a source rock, a better source rock material above this one,
Yes, sir.
right? Great.
Yes,
So
sir.
that's good, well taken. All right. Any other hand? Oh, Prof, your hand was up.
Thank you very much. That was a very interesting field trip since morning. Good afternoon, everyone.
Good afternoon, Prof.
Sincerely, I want to say that this has been a very educative and very interesting fieldwork since morning. I've been following. So at this particular point, I'm just so curious and interested in this section because based on the explanation given already, you see that at the basal part, the marl, they have a thicker section, and as you move up section, discover that those marls are getting reduced. It means that as you go, it means the deposition is seaward. It's now going forward, depositing more shale, showing that the marl will be diluted, the environment is diluted, sorry, and then you have the carbonate now getting reducing possibly, and more of these shades that are coming in. And perhaps you will see that those shades, they are possibly going to be a very fine sandy shade, even though the organic matter may be increasing gradually. And if you look at the bio content will show that you are having more species of plantic foraminifera. For example, it will be increasing gradually, and the shell composition will become calcareous. And then you will now discover that more organic matter is coming into the system. Therefore, as you trace it further, seaward, you will discover that you're having a better source rock in the towards the sea. So the interesting thing is that if this environment is sustained, then definitely it's going to eventually enter into transgressive system tracks where you are going to have your maximum flooding and maximum regression surface before the thing reset back, where you now have your HST later on. So it's a very good section to interpret kind of a petroleum system. Thank you very much.
Thank you very much, Prof. I just feel like I should just pack my bag, thank the Lord.
Let's go home.
Thank the Lord for a beautiful day.
Yeah.
And just go and enjoy for the and thank God for the day. So thank you very much for that.
So if
yes,
when
sir.
a prof speaks, you know that it's different,
There is
right?
nothing more. We should just go home.
Okay.
And thank you,
Thank you.
for sharing. And then also the Fulpre lady. I'm trying to remember your name, who shared very well. Delivered also. And then the chats in the chat room, very well also received. I mean, I see. For me, it's really not about just sharing, but the fact that you are allowed to share what you believe. Nobody is coercing anybody into anything. But if we see it, we're like talk about it, even if it's not the same, but at least let's talk about our observations, even if we don't interpret correctly. At least we can all say this is sand, or this is shale, or this is marl, or this is carbonate. And what we agree on, we build on it. And that's what we're doing here. We're not even going to tell you the answer. We're just going to say, let's make observations and let's see where we go with this. So thanks for the observation. The marl is reducing upwards. Shale is beginning to come in from the bottom parts. It looks like we're now beginning to see more of it. And I also do hear that means we're regressing. We're potentially transgressing because more marine conditions are coming in because that's what is bringing in the shale. And that's why the marl is reducing. And that means we should have a soft rock type material above it somewhere. That's what it is. And I just want to say thanks to everyone who shared observation, representation, and then predicting. And just so you know, the guys who do basin analysis, right, subsurface analysis, this is how it starts. They start from observation, and then they now conceptually link what they've observed to known concepts, and then they now tell you, let's look out for something like this. We should have a formation like this that have this quality around here, and they go hunt for it. They go explore. Okay, they don't just wait on data. They often tell you where to go acquire data. Like we should have a shale or somewhere. We should have sand somewhere. We should have more of marl somewhere. Like you all predicted that we're going to see marl here, and most of us made that prediction, and we were correct because we observed. And we linked it to sea level behavior, and we thought there should be marl somewhere around because the marl was coming more. Now the marl is here, but the marl is reducing, and we begin to see shale struggling and now coming in. So let's see what the last two location will show us. But before then, let me just quickly go to the solution, or rather the summary. First observation here is that we have marl beds reducing with depth, coming shallower. And then I also try to now highlight the shale beds in here also to see, and just so you know, it's not classic observation that, oh, I see shale coming in. What is easier to observe here is that the marl is reducing with as you go shallower. Clearly, the shale may be struggling because sometimes because of where you are or because of erosion, parts of it is eroded. But you definitely see that from the bottom, we didn't see much shale. And then we saw a first chunk of shale, and then we start seeing more of the shale, even though from the general outcrop observation, the bottom parts, we didn't see much. In fact, just milestone all through, basically. So this is it. So this is what we want you to observe. And then if I do a triangle that sort of hierarchically mimics the thickness of the marl, the thickness trend of the marl, you will see that each of these marl is thicker at the bottom, and then it reduces, and then the cycle is repeated. Again, think of parasequences, right? So it gives you a picture of, okay, as these individual parasequences are stacked, what is it telling me? Am I progressively getting shallower or deeper? In this case, we're getting more shale in, and we're getting less marl, meaning we're getting progressively deeper. Meaning, again, the sea level is moving further, basin walls or landwards, if you want to say deeper. If the sea level is getting more, if we're deeper, or if we're going deeper upwards, is the sea level getting more basin walls or more landwards? For those who are pro at this, more basin walls or more landwards? Remember, if a sea level is moving basinward, it is bringing in more of landward material. If a sea level is moving landward, it's bringing in more of Bisner materials. So think about it very, very well. It might be tricky. So deepening does not mean it's going, okay. So I think you get the gist. If a sea level is moving towards you, who is in Lagos, coming towards Ogun, that means sea level is rising. That means sea level is bringing in more deeper materials. But if the sea level is moving away from you towards the beach, more into the Atlantic, meaning all the fluvial deposits, all the deltaic deposits have enough space to find their way into the basin, meaning you call it progradation. The opposite of that is retrogradation. So I think we get the message. In this case, the sea level is moving towards the land because it is rising and because it is bringing in more marine materials. And that is because we see that marl is reducing in thickness, shale is showing up more. Okay, so this is sort of what this whole section of exercise is all about. So that's it for here. I think we will, what is next on the agenda? The next outcrop location is above this one. There are two of them, 7A and 7B. In 7A will be more of a doleritic intrusion, a dolerite seal into the host rock. We will not see more of the host rock, but more of the dolerite seal. And then we will now get to 7B, where we have the continuation of this outcrop. As you all predicted should be shale, we will find out what that is. Okay, so I will stop here and yield to AEIC for the next item.
Okay, we'll move to stop 7 now.
Yeah, I'll get the video ready when we are ready.
Go ahead and play, please, when you're ready.
Okay. Okay. So before we quickly play the video, again, keep in mind where we are in the stratigraphy. We have gone through all the formations all the way from the bottom. We are currently at this place where we had some intrusion into the host rock. You may not see more of the host rock, what you may see with more of the intrusion, but eventually you will see other formation, which is younger. Okay. All right, I'm going to play it in 3, 2, play.
Okay, hi there. Still the NAPE virtual field trip 2025. We are actually at the youngest formation within the Calabar flank. And what we have behind me is the dolerite intrusion within the Ugoro shale. So if you look through the shale, the doleritic intrusives, you'll see some thick, large tabular intrusives here. But within it, although lateritized or weathered, you see the relics of the facilities of the shale showing. So around this area, walking across here, you see the shales following through here, and then behind us here, you see the shale. So this is almost parallel to the bedding. That's why we refer to it as a dolerite seal. So structurally, this was in place within some of the zones of weaknesses within the shale. And these are some interesting features you see within this geologically domain we call the Calabar flank. As we go on, I want you to begin to tell us whether you think that the doleritic material we see here is younger or older than the Umporo shale. That's left for you to decide. Thank you.
Okay, so thank you for that video. Doc, I'm going to now yield to Dr. Romeo and Dr. Cohn for the actual expedition before we do the last integration.
Okay, thank you. So we're at location 7, and like was earlier mentioned, the video was taken at location 7A, where we have a good expression of the doleritic seal. And then at location 7B, which we'll be seeing during the tour, you'll see the thickness of the shale. This is interesting because in the last but one location,
we saw the milestone yielding themselves to thicker shales. So right now we see that it appears to be that we're in a relatively deeper marine section. So so this is where we are. Stop 7. What we see here are some activities of artisanal mining of the doleritic materials here. Well, possibly for construction purposes. Okay, so we'll just take ourselves through the various stuffs here. So what we are doing here, I can see that the link is shared on the chat room, so we can also do this when we download that, move around, pan through, and see the different distribution of how extensive this doleritic body is. Okay, so where we are now is some section where we have the shales expressing themselves. This is along the express road that comes from Calabar down to Dupani. Somewhere around it, we had some what looks like a borrow pit where people were excavating the shales out. So, what's the characteristics of this shale? They are typically very dark gray to black, and then they appear to be very fissile. Studies have shown that they are rich in shark tooth, although from here we see little or none of that. But what is expressive here is some vertical burrows in some cases, and then we see septarian nodules. Okay, so those are the genetic features. Going around this top, for instance, we take a closer look here. You see the thickness of the shale up here, and then at some point up there, the shale gives way to sandstones of the Benin Formation, loose sandstones. Okay, so another closer look at it is a photograph on the slide that still shows the shelly unit. Okay, so here it's a short video tour that takes us through the doleritic rocks that have been broken down by artisanal miners. This is a closer view of it. So people think that the white spots on the dolerite are zeolites. So studies are being carried out to pick that. Okay, so this gives us different view across the Umpuru Formation. It's also one of these are the spots you see on the mouth of the dolerite, the surface, sorry. And then tiny, what is shales, laterites, howbeit and weathered in between the different phases of the dolerite. And then here you see some sort of galling that assists in exposing the surface of the shales. These are the Uboro shales. All right, so they are dark gray, and in some places we find some traces that may not be too clearly visible here. Okay, yes, so we can see some of them here. So so what would you see is cylindrical, some vertical, see them scattered around. Okay, so the weathered portion of the clay, the shales is highly clayey. The shales are dark gray. There are some points where you have sectarian noodles, that genetic feature, and then at other places you begin to find that they are highly fossiliferous. So these are the typical characteristics of the Umporo shale. And subsequently, after the Umporo shale was actually deposited after the Santonian deformation episode that affect most of southern Nigeria, especially the southern Benue Trough. So it serves as the cap of the Cretaceous stratigraphy within the Calabar flank. This is important to note. And then some of the stratigraphic development within elsewhere, southern Nigeria, like the Anambra Basin, took shape, from the Oro Formation and its lateral equivalents as their oldest forms. So these are some of the characteristics of what we have here. We have seen most of all this, and it is important to note that the Calabar flank segmentation, well, I will leave that open for us to think, terminated during the end Cretaceous, that's the Maastrichtian, and then whether or not the Niger Delta sits upon the sediments of the Calabar flank at this time with the deposition of the Benin Formation. So these are some things we should bear in mind before the activities come forth. So we look at it from the paleogeographic perspective so that we can get a holistic picture of the Calabar flank. Once again, we're in the late Campanian to Maastrichtian times now. What a long journey from the Aptian times up to Maastrichtian. Thank you.
Awesome. Dr. Romeo, are you good? You want to chime in? Or that's it? Okay, so Dr. Ifeanyi, over to you. So, but before you said something right, I remember during this field trip, I came in from the Younger Granite Province, and for me to be seeing a doloride intrusion down there was a big thing for me, yeah. So that memory stuck with me. I had to pick up that sample and take it home with me and put it up on the table, my study table. I look at it every day. So to me, it's like I have never knew such thing could ever happen in a sedimentary terrain like that. Because someone who has been within the Younger Granite Province, all I know is hard rock, solid rock geology, was an eye-opener. It changed my perspective completely about the geology of Nigeria. Yeah. So that's Calabar flank for you. Anyway, Dr. Ifeanyi, over to you. Hello, Doc.
Yeah, thank you very much. Yeah, it's sometimes amazing how you go through almost a life, a decades, and some things you just haven't seen. So, which is why these field trips are very, very helpful. We hear the saying that the best geologists are the ones that have seen the most rocks. So, if you are a geologist, and you haven't been seeing more rocks, and the last time you saw a rock was in your finals of masters or your BSc, and now you're working, you're doing very well, and you haven't gone out to see more rocks, you need to have a rethink. You need to
Absolutely.
have a because this is fun going back there to say, hey, see these rocks and have a chat with them. Okay, so we just finished. What is the next? And is it the team exercise or the integration?
Integration.
Or we need to go through the last location 7B. We also have that, or we went through that already?
Yeah, we've gone through that already. What we have is the integration right now.
Okay, so let's do the integration piece. I will just maybe just sort of do a reminder. But there's an activity that is tied to this other one. I think we should do that activity first.
Okay.
Activity 5, which is tied to location 7. Okay, let me do the activity for now before we do the integration piece. Just give me a second. So get ready for those who have done the task. Get ready to share. Even though I did a flip in the questions, but I think it's the same thing. So let me know if you can see. There's a hand that is up.
Yes,
Do you want to go
that's
ahead?
Mariam, right? She's
Yes.
asking for clarification
Okay.
from the literature on coral shell was said to be oldest formation in Nambara Basin. How can it refer to as the oldest here in Calabar Flank?
No, it won't be the oldest in the Calabar Flank. I mean the Nkporo Shell, right? It will be in the Anambra Basin. But we have the equivalent of the Nkporo Shell, outcropping in this area. The question is it part of the Calabar Flank? Is it not part of the Calabar Flank? To be honest, I'm not interested in those argument of does it belong or does it not belong. But I think what we'll take is, in terms of age, Nkporo it's much younger than every formation we've seen in the Calabar Flank, from the oldest Awi to the more recent new Netimal. So it's the youngest. Okay, that's what you mean. That's correct. So it is the equivalent of it that we're seeing here. And I think I'll assume that the dating is part of why it is interpreted to be Moro Shell. So it can be oldest in one basin, but in another basin, it just lies. You will see the next section we will show. The next question will be that, do we have an unconformity between the Moro here and the formation above it, which could be interpreted as maybe, continental sands of the Bini formation? That's a big question. But yes, it can be old in one location and another location is the youngest. It happens.
So, Doc, if I
Yes, sir.
So just to add something to that, to be helpful to those who are walking around the area, sometimes within the Anambra Basin section, you have some conglomerated sandstone associated with the base of the Nkoro Shale. But so far, we have scarcely found that within the Calabar flank. Maybe we have not drilled or seen better exposures, but so far from what has been found and some of the work we've done around there, we've not seen that typical, when I say thick conglomerate, very thick conglomeratic sandstones. So, well, I don't know how that plays out, but I think that there's been something in between. I know about the Santonian activities, but how well the paleogeography differentiates them from the Calabar flank, and that is something that could be instructive.
Okay.
Fine. Yeah.
Okay, so yeah, thanks, Doc, for that one also. And I think this is also saying this is not the answer, it's just observations and current representation and interpretation. Things can evolve, and besides, we have the room to have more than one school of thoughts. The more important thing is, what have we seen? What have we observed? The more data you get, the more you really refine your understanding of this area and these formations and where they belong. Okay, so now let's move on to this small task. I think this was also shared in the chat room. So I think in the last location, New Netimal, before we looked at the dolerite, you all predicted, or rather most people predicted, that we expect to be going into more marine conditions, because you looked at that mile and you observe that we have more shields coming in. Let me go back to it for 1 second. Okay, you have mile reducing shield coming in. Okay, and then based on that, you said, okay, the next formation will be more shelly and more marine, and that is exactly correct. Okay, so this is it. We're now in Nkporo. Incidentally, we'll be seeing not just Nkporo, but also the Bini, Bini formation, continental sand. So this is the section in view. You see the shale and you see the sand just sitting right on it in this location. And I hear from Dr. Okon and team that this location is fresh. It's not been like this. So this is actually helping the understanding of the Nkporo as they know it in the Calabar flank, in terms of where you can see outcropping sections. Right, so now the first question here is comparing the Bini formation, which is above, to the Nkporo shell, which is below. what would you say about the environment? Shallower or deeper? I know by now this class is made up of experts, so we should all just tell us the answer without waiting. No time. And then the next exercise will now be attempt to draw a log. What do you think? But I see a hand up. Please, let's hear from you, Brume, before we move on. Someone can unmute. Brume, you can
Yeah,
unmute.
Brume, go ahead. I think he can speak. Brume, speak. Okay. Do you need to be unmuted?
Okay. Okay, the environment is getting shallower for the A part.
Oh, okay, you're giving us the answer. Oh, wow, that's cool. I love that. I thought it was a question from yesterday, but you're already in the future. Thank you very much. Okay, great. So any other response? You took me on unawares. I wasn't, I was thinking you were going to say, wow, what else? Something of the past. Okay, shallower, shallower. I see that. I think by now, this crop of people we have here are not normal people. You are not normal people. You are not supposed to be in this class. You should pay more. Okay, so let's just move on. This is the resolution. And then the second one is attempt to draw a gamma ray and density log. If we draw a gamma ray hypothetically, right? Hypothetically, yeah, Balumi, let's hear from you. Go ahead, Balumi. Unmute.
So before Pelumi talk, right, this reminds me of sedimentary geology when you're sorting grain size, right? We started with almost like 170 something. Now we have about 79. So there's a real good sorting. We have very fine grain that have stayed with us all through the sequence until this point. So they are already soaked in the entire geology. Yeah. So Dr. Ifan, don't be surprised. You have your answers before you even ask the questions.
Yeah, true. And it makes you feel good as a lecturer, as an instructor. You feel like you're the best in the world. Meanwhile, the students are actually the best in the world, not you entirely. But let's move on. So let's look at the reactions. Okay, more reactions, smiles coming in. Beneath formation is shallower water fascists compared to overlying Boro. Okay, I guess we know where we're headed with this, right? So the answer is saying that it's getting shallower. That means the sea level is moving. If it's going from Oro to Benin, that means the sea level is moving landward or basinward. One more final test for this. Is it moving basinward or landward if you think the sea level is getting shallower upwards? Okay, is getting shallower? Yes. Sea level, okay, means basinward. Okay, that first person, Victor Guinea and et al. Victor et al. Well done. You guys will write a book on sequence stratigraphy and petroleum system analysis already. Okay, so this is the answer. This is an hypothetical log. It's a poor man's version, and the person just tried to just quickly make an interpretation and say, I think I'm getting deeper in this Boro shale, but by the time I get to that boundary, I switch to coastal conditions, continental conditions, which means I'm shallow. So across it, there is an unconformity because you have juxtaposed coastal delta juxtaposed against marine, so there's potentially probably something missing in the middle. If you had gone from marine to maybe shallow marine to, before you get to coastal delta, Water's law is obeyed. But in this case, it looks like there could be one or two sub-environments that are missing, meaning they are not in obedience to Water's law. This succession does not obey Water's law. It means there's some environment that we've jumped or we've skipped, which also means that there is an unconformity and the abrupt shift from Boro shale, which is marine, to Benin type sands, Benin formation type sands, which is coastal deltaic. It's abrupt because there's something potentially missing, right? Because you can't suddenly go from Abuja to Lagos if you're going by road. You have to drive through Lokoja, go through some place, get to Benin, get to Ore before you find your way in Lagos, except you're flying, which is different. So well done, everyone. This is well done. The next question that says attempt to draw a gamma ray and density log. I think I'll just jump to it. This is the answer. If we attempt a gamma ray, of course the sounds will have lower what is it called? Lower radioactivity, so it will be lower gamma ray. And then, except you're talking about acoustic sounds, which might have higher, or feldspathic sounds, which will now have, or hot sounds, which will now have higher gamma ray. But if it's just ordinary sound with less K40 and all of those, it's going to be this. And then shale will have higher gamma ray generally because they have higher radioactive content, right? And then density-wise, overall, for a normal compaction trend, sands will have lower density, you know, than shales, which have higher density. Again, this is not to scale, it's just, you know, just to do a little bit of a while and log exercise. So well done, everyone. We will just go into the next activity, which is the integration piece. Okay, integration piece. Now, this is where we started. We started off at location 1. Okay, this is not an exercise. It's just let's all observe together. Location 1 was largely basement, which is in the continent, which, well, is continental environment right here. So this is just more like an analog, all right? That, if you remember where we went to that first location, it was largely basement. The second location, we didn't quite see a lot there, but we now also went to location 3. You know, the second location, we saw sand, the Awi formation with basement, you know, at the bottom, right? And then the third location, we didn't quite go there, but generally the third location is the basal part of the Awi formation that has a lot of iron ore, which tells you a lot about the past climate, paleoclimate, you know, reducing conditions, or oxidizing conditions in a humid environment with warm temperatures. That's why you see all of these reddish lateritic materials with iron ore here telling you it's largely, you know, of that environment. And then we now moved on to the next actual second location was here, where we saw the basement rock, igneous, metamorphic rock with igneous intrusions. And then we now did all the observation on those sand fascies, right? Yeah, you know, they repeated finding upward sequences with pebbly bays and finds upwards, and we talked a lot about the shells, about the connectivity and grain size and all of that and sorting. Now, this is where that environment falls. If you look at your top right, that is just saying you have like a basement complex uphill, and then just adjacent to it, you have deposits that have not gone so far. Some people might actually say alluvial, but generally they are just close to source, basically. It could also be fluvial, but then it hasn't traveled so far from the source, because we saw that they have a lot of pebbly bays, they're largely polysorted. In some cases, you have some cross beds, and all the signatures point to, again, fluvial, continental. Now, we now moved on to the Formosan limestone, where you saw those limestone pillars, okay, standing very, very firmly. Those are like remnants of a much larger limestone terrain, which I understand was all over the place, you know, is currently being mined and is still being mined for use in making cement and others. So these are the remnants, basically. There are a lot of it standing out there in the past and still being, and then with caves, you know. So those limestone, of course, indicates, you know, shallow water conditions. If you notice, if you look at this section here, if you can see my cursor, that is the limestone sitting on top of the Awi formation on what was called, I think, the Ikpef platform. Is that the Ikpef platform, if I'm right? It took high. Yeah, it took high, basically. The Ikpef platform is the boundary to the one binding the basin to the west. Okay, so this is the Ituk high. So on those highs, that's where you see these limestone features telling you the way carbonates form, right? There is some interaction between the water depth and sunlight. So sunlight is required, some kind of sunlight is required for those organisms to survive. But then as water is also deepening, they're buried and they die in mass, and they die, and then they form the limestone rocks. So it's telling you it's marine, but not so deep. right? So which is why this is shallow marine. And then we now moved on to a Kenkbom shale where you saw those very beautiful looking shales with marl interbeds capping them. And then we talked about parasequences. We talked about the thickness trends and whether things were going to get more marly or shaly. So in real life, this is what the marine will look like. I'm sure not every one of you will like to go all the way at the bottom, except you want to go diving. I haven't done that, but this is not for the faint-hearted. This is for divers, right? So we now move from a Kenkbom shale. We now move to location 6, where we saw the Mile, as you rightly predicted, which is still marine, but it's getting shallower. Marine conditions, but the sea level is beginning to show some other behaviors. At this very time in the new netting Mile, it was shallower than the previous location because we have more Mile here. Okay, and then above it, we do now have the dolerite intrusion into the host rock, which wasn't very clear, except that you could see the dolerite intrusion very clearly. Okay, but then we also now predicted that because we already saw shale coming in new netting Mile location 6, we're going to see more of it somewhere. And you rightly did predict that. We now have Mboro shale in the location 7B, which was very well represented. It couldn't be any better than this. But above the Mboro shale is marine, but above it we have the Benin, which largely is shallower condition, coastal delta conditions, just as you can see here. You can agree with me that these water depths are not the same. Okay, this one is up in the surface. For those of you who are familiar with Lagos environment and some beaches around town, Calabar also have some nice environments, Port Harcourt, so this is sort of putting it together. So the point here is from the oldest to the youngest in this formation, typically what we would like you to do will be to say, okay, where in a 3D model, where would this fit? Okay, where would this hole fit? And this is just an example. So location 1 will be more up in the basement area. Location 2 is where you saw those where you talked a lot about the reservoir behavior. That's somewhere between the basement sitting, somewhere close to the basement where you have those, conglomeratic fanning upward sands sitting unconformably on the basement. And then we begin to see more sands. And then by location 3, okay, we didn't quite go to location 3, but location 4 is where we now saw the limestone, right? The Formosan limestone. That is shallow marine. So it's right here. It's not so far away from where you expect it to be. So I think this placement of location 4 could actually move. It was meant to be shallow marine, which is, well, we could also pass. It could be more further out, not where it is currently, right? And then location 5 is the Kenkbom shales, and that's where those were interpreted as marine based on the features and all the sedimentary features seen. Okay, location 6 also marine, but it's getting more shallow. So maybe if we want to adjust this, let's do it together. Location 5 can be right here. Location 6 can be more further backwards, right? And then location 4 can just be somewhere where you have some form of, close to tidal influence. So I wanted us to make these efforts again almost together. So something like this will suffice. Okay, so you see that location 5 is further out, a Kenkbom shale. Location 6 is just still in marine but getting shallower. And then location 7, we saw Mboro shale, which is marine. We also saw the Bini, which is coastal deltaic. So we will go with the shallowest in this case. Let's say it's somewhere in the coastal plain setting. You have a bunch of those sands. And then I think there was no location 8. There's probably 7B that was mislabeled. Okay, so this is sort of putting it together, right? Think about all of this. Behavior of the sea level through time has really impacted what we're seeing. And the next part of this will be, look at a section like this. Where would you say the source rocks are? Where would you say the reservoir rock or rocks are? And do we have a trap? Those are the 3 questions that I want us to round off with. Identify possible source reservoir and seal rocks? Are there traps? And then any other discussion on the hydrocarbon potential of this basin? And then the floor is open for comments. Do we have source rock? It doesn't matter what. Do we have rocks that could be source rock? Do we have rocks that could serve as reservoir? Do we have rocks that could be seal? Identify them and what's the name of the formation. And then we can now talk about whether there is actual oil or gas or not a little bit before we go. Any thoughts? Anyone want to share? Do we have source rock for a start? Let's start from there. Is there a source rock, reservoir rock? Let's start with question 1. Tell us yes or no if you think so. Okay. So we have yes, we have yes, we have yes. So any volunteer to just take the bull by the horn and just give it a trial. Which formations do you think could be source rock or reservoir or seal rock? That is just for a moment, ignoring whether they're the best source rock or best reservoir. Just mention their names. Okay, so type it in. Source rock equals ABC formation. Reservoir rock, ABC. Seal rock. Let's do that because this is where we, yeah. Yes, Prof. Allow the students to speak. Thank you. Yeah. Okay.
Hello,
A
Doc.
hand is up, so go
Can you hear
ahead.
me?
Please go
Yeah,
ahead. Yeah.
Pascal.
Okay,
Raise
so
up your hand. If you did, go ahead.
can you hear me?
Yes.
Okay, so this is my opinion, what I think. I think the Ekembo shell could be a source rock. The Awi formation could serve as a reservoir rock with the faulting down there. That's the host and graben faults could be a trap structure with the limestone acting as a seal. So I think that is a possible petroleum system that could exist in the Calabar flank.
Cool. Thank you for that perspective. Thank you for sharing in very, succinct terms. Any other view? Any other idea? Let us hear from you. More hands, more responses, please.
Brume, you can go ahead.
Okay. Good afternoon, everyone. So for me, I think the seal could be that Nkoroshi, Ekekpo, or the new Metima. While for the reservoir rock, we have Awi Formation sandstone and Mfamusi limestone. While for the source rock, Nkporo shale and Ekekpo shale are the possible source rocks.
Thank you very much. So someone should be typing it in the chat room. Any other view? Maybe one more or two more before we go. One more. I'd like to hear your beautiful voices. Okay. Okay, let me go to chats. I think people are already doing this excellent work. Kenkbong who acts as source rock. Let me know this. Yeah. I guess everyone is really getting the gist. Boro, potential source rock, of course. Yes. So yes, and yes, well done. So this is it. Of course, you already all got the gist. The basement is basement. Basement is just there. I don't even know what the role is of the basement. Just cooking up the rocks and just acting as a saucer. Okay, so the Awi Formation potential reservoir, correct. Very well said. Okay. Do we have migration pathways? Potentially, yes. Those faults are there as migration pathways, to let things connect. And another potential reservoir, I don't know if someone mentioned it, the Infamosin limestone. Limestone can serve as reservoir and source at the same time, right? Okay, great. Someone mentioned. So yeah, Infamosin can also be a reservoir rock, can also be a source rock, depending on what organic matter it's made up of. Yeah, and sometimes maybe even seal. But yes, Awi and Infamosin are potential reservoirs. And then which other thing can be reservoir? The Mal is not a great reservoir. It's just somewhere, I don't know. It's not a great one at all. mostly more of a source rock type, even if at all. Yeah, and then beneath formation, of course, is all the way at the shallow. It's by default, it's called source. It's called reservoir. And then source rock, a camp bomb shale, yes. Even the Infamosin, potentially, there are animals, things that die and form the limestone. So organisms might also, it might give a type of organic matter that is rich and might also be a source in some instances. New Netimal, I'm looking at this formation with one eye. I don't trust it entirely to give me source, really. I don't, they say the way we say we look at you with one eye, that's what I'm doing. Yeah, but New Netimal can pass as a seal. Yes, yes, I think it can pass as a seal. It has that potential, even though the sales content of mals can actually do them and can make them struggle, right? But generally, it's not, it's sort of fine-grained. It's not like sand, basically, right? Indurated also, but the the sales content, the grittiness in mal might be an issue, right? So it may not be a great seal, but yes, it's in the absence of any other better one. Yes, it could be a great seal. And then every source rock that is shaly, many times can be sealed by default, like in Boro, a camp bomb by default, Yeah, I think we all got it. At least we have all the options listed out. I'm really glad you're thinking about it. And then the next question would be, okay, what do we expect in terms of prospectivity? Do we expect, I understand a lot of work has been done here, largely type 3 organic matter, which means what we had in place was more of terrestrial materials that got buried, died off, and led to most of what we're seeing as the organic matter content, not type 2. So, and I also understand that Oro seems to be a much better in terms of maturity level, more mature than a camp bomb shale in terms of the maturity level of both of them. They both can be source rock, but Oro is better, especially in some other locations where you see oil seeps or where you also see indication of dark fissile materials. So, and then the beneath formation, we all know is always there to collect things, to collect oil. Okay, so these arrows are just pointing potentially, let's assume that the camp bomb shale is a classic source rock. It's going to generate the oil, and the oil will find its way into the nearby reservoir, which will be the Awi formation, and also maybe the Formosan limestone. But then the question is, what's the organic matter type? Are they mature enough? Has it, that's another part of the discussion. And then secondly, it looks like the beneath formation is also just well positioned to take up the oil from these other formations like Boro, which is why it is not surprising that the Niger Delta Basin is just doing very well. So everything that seems to not work very well in the nearby basin, the oils, when they eventually mature, they find their way up deep and they get into the Agbada, Akata, and just the nearby formation. So this is sort of, again, prompting you and I to think, what is the source rock potential here? I know a lot of work has been done, type 3 organic matter mostly, not so entirely the oil type, and there are indications of what is it called? Oil seeps in some part of the Anambra Basin. I have seen that in Ugueme, and then you also have gas flares coming out in some part of the Anambra Basin. So these are all indications that most of these areas seem to be more of type 3, and it tells you why it's not entirely the oil type. And then the Niger Delta now has its better inputs from the source rocks that are mature. So that's sort of where this is going. The source rock, the reservoir rock, the sea rocks, you've been able to identify them. And I also think it will also give you an appreciation for what this basin is in terms of its gas potential, in terms of what could also be a trap. Where do we need to go to? Which, again, you've also rightly pointed out, and all the formations also and their potential role as petroleum system elements. So that's where I will draw the curtain for now. I don't know if there are other comments. Otherwise, I think it's been a beautiful class, and you've been very much in the lead in terms of following and also giving your response. Thank you very much. AEIC, I will yield for you and the team.
Okay. Is this a good time to give our instructors a very good sound round of an E-clap? Please, everyone, make sure you do that. Oh, awesome, 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 awesome. You guys have been amazing. Thank you, Dr. Ifeanyi, right? So with this, I will not make an attempt to do any form of recap. No, because that is not necessary. Justice has been done to this already. Okay, so I will take the next 5 minutes to just give us a heads up to what lies ahead of us. But before I do that, I need to put it on record. This year's virtual field trip wouldn't have happened without some key stakeholders, like I said at the beginning, for those of you that didn't join. And the first person I will talk about is one, NAPE, who have gone into collaboration with DigiConnect. Thank you, our sponsors, for sponsoring this year's virtual field trip. Thank you, DigiConnect team. I'm sure they are still on the call. If you can hear me, please let me have a response from the DigiConnect team. Thank you so much. We look forward to future collaboration with you in terms of this virtual field trip. We haven't covered all the bases yet. So guys, stay close. Virtual field trip hasn't ended even though COVID has finished. The main aim is to be able to document and preserve all our outcrops before they go extinct so that we don't have to dig further to begin to study geology.
Thank you.
All right? Thank you, DigiConnect. Thank you. Thank you, Dr. Ifeanyi. Please, everyone clap for Dr. Ifeanyi. In a way, he is like the silver lining. You know, when you say the silver lining, right? You already see, you know it for yourself. I don't even need to say it. If you have been following virtual field trip for the past 3-4 years, you will know that Dr. Ifeanyi has been very instrumental in the success of this virtual field trip. And then I won't stop there.
Thank you,
We
sir.
have
Thanks,
our foot
everyone.
soldiers. Thank you, Dr. Ifeanyi. We have our foot soldiers, Dr. Okon and Dr. Romeo. God bless you. Thank you for taking the risks. Thank you for taking the pain. Thank you for making sacrifices. Even when you were not financed in any way, you went to the field amidst the rain. It was like the virtual field trip will not happen, but it did, right? So that is a very big sacrifice we need to know if that has happened behind the scenes. You don't want to begin to see the behind the scene pictures of us going to mud and all that, being beaten by bees and all that. It's been an amazing experience. Of course, again, that's part of being a geologist. That's what makes you an earth scientist. All right. Thank you, guys. They are not being paid to do this, mind you. Nobody's been paid to do this. This is like volunteering. This is like them giving back to the society. Thank you. Victoria Okore, you are not here, but your presence is being felt. Dr. Sunday Amoyede, the immediate past AEIC. You know, when they call silent achievers, right? There are people that you don't even probably will know they exist, but they will just do what they need to do and move. Dr. Sunday, if you're on this call, thank you for your contribution to this year's VAFT. Okay? God bless you. Between you and I, you know what happened behind the scene. So well done. Well done. Austin, this stance will not be complete without saying a word to Austin. From day one, Austin have been the architect that takes the footages, both still and video, to ensure that the package that we have today is being fitted nicely so that it makes sense. It's a lot of effort. You have drones flying in the air. In fact, we almost lost his drone this year's field trip. We had to pray in the field and call it forth for the drone to come back home because at a point we're not seeing it. So that is a risk with no insurance of any form, right? Aside the cameras and equipment that he takes to the field are worth millions and millions of naira, right? Thank you. And he is doing this virtually for free for NAPE. If he's going to charge what he should charge, we probably wouldn't be able to afford it. Thank you, Austin, for doing this. And to all the professors, Professor Wade is here. Adeke is here. Professor Mode in Essential. And so many of them. I don't want to start calling lists in the VFT team WhatsApp group. Thank you for your sacrifices. Thank you for your contribution. Thank you for the what will I say, the authorization to even have all the footages that we didn't have in order to prepare to go to the footages. Without you making this provision, we wouldn't have had a good reconnaissance before we even set out. So thank you. The list can go on and on and on, but I would like to stop here. All right? Stay on with us. The next VTF is going to be mind-blowing, and I'm not going to let the cat out of the box. All right? When we firm up discussion with DG Connect, then I will come back to you with detailed information on what will be our next location. But I can promise you, it's not going to be it's not going to be anything short than the best of the best. All right. The aim is to map out all the basins and all the other features that need to be preserved. That is our target, and we're on it. Thank you, DG Connect, for the motivation behind this.
I see.
Yes,
Yeah,
sir.
Before they go, let's do a picture capture.
Yes, please. Everyone, put on your camera. Yeah, before
Yeah.
we lose everyone. Even though
Before we lose
everyone is
people.
still here, just
Yeah.
1 or 2 people. Please put on your camera. Let's do the traditional picture. Let's see your face. Let's put face to some of
Yay,
these
my
names.
different folks.
Oh, the
I
Digi
see
Connect
you.
people. We see you.
We see you, man.
Yeah. Where is Oladipo? Where is she? Where is
Yeah.
Madam?
All my guys.
Is it
Sammy, my
Pato
man,
K?
I see you.
Where is she? Where is Dr. What's his name?
We can unmute everybody if we
Please
can.
unmute yourself, right? This is the time to unmute.
Okay, where are you?
Good to see everyone.
Good
Yes,
to see all of you.
Testimony. I see your hair.
Yes, so good afternoon.
My guy.
Well done.
Huh?
Thank you.
Well done.
So,
yeah, Fejiro, well done. Thank you.
Tunde, do your thing, right? As we're doing all this chit chat, please.
Please, just hold on. Just hold on.
Everyone, put on your camera. It's going to go page by page and get some screenshots for us. Hi, guys.
Yes,
Hi, guys. The Digi Connect team, you know yourselves there. So, Tunde, do your own thing, right?
Just hold on, please.
Let us
good
know when to
pictures.
restart the smile so that it will be at its peak, you know?
Yes.
So none of you is acting of the EIC.
EIC, we know
Yes,
you are in
sir.
spirit. You are here in spirit.
Hello, fine.
Yes, sir. Oh, good.
Greeting you.
Thank you, sir. It's good to
I've
see
been
you.
listening as well. I shut off mine and I was listening on theirs.
Oh, wow. Thank you very much. It's good to see you. Thank you very much, sir.
Good to see you too.
Yeah.
Awesome. So, guys, grab the screenshot. Let's have some memories, okay? Let's have some memories. As many as you can grab it and drop it up on the VFT WhatsApp group. Okay?
Somewhere, I can't see your face, so somewhere. I can't see someone's face.
Dr. Romeo, why is your camera off? Okay. All right. Tunde, are you good?
Are you not seeing Dr. Romeo?
Okay, good. Let's all converge. So we behind the scene, you can see us all here, right? That's Dr. Okon, that's Dr. Romeo. We have Abraham there at the back. All right. So please, Tunde.
EIC.
Everyone say
strategic.
Okay.
Thanks. Well done, Tunde. You can see more people, right?
Yeah, there's about how many of us? 14.
Oh, but I know there are more people who are also trying to unmute or remove their video.
Okay, I think they won't be able to do
They
the,
won't be able to.
should I promote? Do you want me
Promote
to
promote
everybody.
all of
This
them.
is
Promote as many as
closing
you
ceremony. Promote everybody.
That's the idea.
Automatic. Your promotion is here.
Promote everyone.
Okay, I'm doing that already.
Let's do mass promotion. Everybody, if you have the power to promote someone. Add them up.
How do you do that?
If you are not promoted, you're wrong.
Please, for those that have sent requests, kindly confirm and you'll be automatically promoted. Thank you.
Quickly.
Confirm all of you on me. Yes, the number is increasing now.
Yes, let's promote people. Everybody, let's all help out with the promotion. So that
Please help. If you're already promoted, help other people.
Let's all do that together. Get everyone in the room.
Don't be left out.
Okay, just hold on.
Is it a promotional exam that you are doing?
Yeah, I see. What is your problem? Oh, yes, it's like, Prof. So have we gotten everyone here? Okay, just a few more people.
Yeah, we still have some to go. Samuel, please help me from your own end.
Man, I feel good being a promoter, like promoting people. This is good job. I feel like a good man right now.
Okay, promote.
If you have been promoted, you have the power
Please
to promote.
accept.
You have to accept, yeah.
Yeah, if you don't accept, you won't be promoted, huh?
This is first promotion.
I'm doing as many as I can.
People to be promoted.
Yeah. Awesome. We're getting more and more people. As I'm clicking, please be accepting. Tunde, be doing it on your own end too. And we miss, where is Austin now?
Okay, so I've done majority of promotions, so it's for the majority to accept the promotion.
Okay, I think we can go ahead then. Let's go ahead.
Okay, now let's do it now.
You know, in life too, there are people who, if you promote them, they will tell you not now. We have to recognize that scenario. And it's for a good reason. So.
Okay.
But if you still want promotion and you are still on the other end, you can raise up your hand so we can give you special attention.
I am clicking, they are accepting. They are accepting. We're almost there. Less than 20. Okay, who is sharing the screen? Somebody should stop. Please don't share your screen. Don't share your screen, yes. Okay. Are we all there?
I think we're good. Maybe one or two more.
Okay. Okay. They're still accepting.
Okay, I think we can. All right, let's go ahead then and do this.
Okay. All right. Everyone say Mushi. Okay, I got one.
Okay, I think we've had enough of.
Why is that?
Thank you.
Okay.
Thank you.
Yeah.
All right.
Sure.
Peace out, everyone. Thank you very much.
I'm sure you'll get to the next page.
Bye. Thank you.
Thank you very much, everyone. Please.
Austin was here. He was just quiet.
Give your feedback, please.
Feedback form, please. Feedback form.
You guys know, what we used to do in school? Austin was here. You know, you go to an laptop and write something. All right, bye. Thank you, guys.
Thank you, everyone.
Enjoy
It was a
your
nice
course.
one. It was a
The
nice
short course
one.
is tomorrow. If you have not registered, go and register. Okay? If you are having challenge, reach out to me or Tunde or Mayowa. They will help you. Or Lawrence.
All right, bye-bye, everyone. Thank you.
All right, bye now. Bye.
All right, thank you.
Okay, bye everyone. Thanks for joining.
Bye. Thank you so much. Please don't forget to
See
fill
you
out
at the
your form,
conference.
the feedback.
Hi, Professor Jolie. Edu Zari, I
Yes,
can see
bye.
you.
Yeah, they don't really
Hi.
get it.
Thank
Good to
you.
see you.
Thank you. It's nice meeting you here.
It's a pleasure.
Mr. Dong, I hope we have back-end pictures. I hope we have the pictures from the back end for our publicity.
Oh yeah, well, we'll have that.
Okay.
Yeah, I'll send it
Pedro, why are you smiling like that? Why are you
Because
smiling
I
too
know,
much?
I know, it's after publicity.
You know you're a person, right? That's nice. Awesome. Good job. All right, Cindy, when you're ready, you can end it all for all, right?
It's okay, so we can end it. Thanks everyone.
Okay. Thank you, AIC.
We'll see you guys later.
Yes, sir.
I have enough pictures to send to you.
Okay, please, go ahead. We have a publicity to do. I'm sure Isa is happy and Fejiro, they're all happy hearing that.
Very happy.
Publicity committee. Where is Marietta? I've not seen Marietta in all this. Dr. Ifan, did you see her brake light here?
Where's Mayo? Mayo, didn't you?
It was with you in spirit.
Mayowa is busy. Mayowa is busy
Without
doing
Marietta, this
membership.
thing should not have happened.
He's collating names for me for short course.
So I'm stopping the recording.